Welcome everybody. It is Tuesday night and I am MC Toon, your host for the evening. I hope you're ready. We have some excellent debates in store. Well, debate singular. One debate between myself and Nathan Erickson, who goes by Pitch Lumen as well. That's his YouTube channel, Pitch Lumen. Nathan is a really nice guy. I've met him in person. I went to coffee with him and Brenda this summer or fall, and we had a great time. He's super nice. We've emailed back and forth several times, and it's always been good. So if you were around last week, I expect this to be the exact opposite of last week. So, and I'm very confident about it. I've interacted with Nathan enough to know him good enough that, yeah, this is going to be good. So if you were wondering, wait a second, what happened to that debate with David Beverly, the former NASA employee? That got pushed back to probably 3 weeks from tonight. The host, Dan, hold on, I want to get it right. Bondi, I don't know. Hold on. I don't want to, there it is. All right. It's, he had a thing, a conflict tonight, and so we're like, yeah, let's wait. So Dan Bidondi is his name, and David Beverly. So there's that. Then tomorrow, 6 p.m. Central Time, so earlier than tonight, I am on Jeranism with Vika Drazeev. Vika is a flat earther that did a video called The Mechanical Realm. And he likes to talk about the Antikythera mechanism. Will he show how the Antikythera mechanism was designed using flat Earth geometry? No, he won't, of course. It will be many assertions, or will it? Spoiler alert. Yeah. So anyway, that's tomorrow. Be looking out for that. I'll probably put up the live stream thing tonight. So, yeah, Syro cycles, metatonic cycles, all just basically tables of numbers. So anyway, there's that. That'll be interesting. Tomorrow we have exchanged topics. We've exchanged questions. Jaron likes to do that. I like it when he does that, because if they can't produce an answer, given time to produce an answer, it says a lot. So anyway, so it is now 7:50 Minnesota time. The debate on Modern Day Debate starts at 8. So I will be focused on that there, not here as much. So if you do want to do a super chat that you want me to answer on Modern Day Debate, do it over there. There. If you want me to do something, interact with me here, I will be coming back here after I'm done on Modern Day Debate. So I'll be back from there over here for an after show. Maybe if there's some guests or something, we'll see if anybody wants to chat a little bit. So I'll read the couple super chats I have here. Oh, and one hint, and maybe some moderators want to remind people of this. If you do go to Modern Day Debate and you want to ask questions that kind of poke at Flat Earth, a good thing to poke at, you might address the question to me, because then I will get a chance to talk and show how Flat Earth can't answer anything. Just a little hint. You do what you do yourself, but just a little pro tip there if you want. Yeah, I know there's a lot of people banned over there. So I'm doing my part to try to fix what I think and what you think is a problem over there. So that's what I'm doing. My part to try and fix that. So, okay. But I am going to be getting on the Zoom call here. So you will again see, like last week, the making of the sausage. So a little bit of behind the scenes stuff while I join in over there. There it is. Okay. And so I'm joining the Zoom call, and I do have to set up some things here. I'm not in the got to get the modern day. You want to have the modern day debate call on there. Ooh.
Made them
Trilogy?
all and reskinned them. Yeah. What one are you playing right now?
All right, so you hear
Yeah, you're playing. Oh, she's playing the third one.
you hear them talking. I'll get them on
Okay.
in a second.
All right,
Oh,
that was
no.
good.
Oh, actually, never mind. She just said she's playing the first, which is the hardest one. Honestly, like there's like 8 worlds in that game. I remember being a kid and just being like, I'm never gonna beat this game. I did eventually,
Right.
but
The levels
it,
keep coming. So yeah.
how's it
It's a
going?
fun game.
Oh, are you
How you
asking
doing
me?
today? Well, I'm asking everybody, I guess. How's it going, McToon? How you doing, buddy?
It's great. I am live like
Yeah.
last week, so
Under better parameters this time, I'm
yeah.
sure.
Nathan is the nicest guy around, so we've got
was
we've got that
competition.
going for us tonight,
That's
which
that's
is
good.
good.
Does your
Hey,
live chat mind if I go fix my hair right quick? Look
Oh,
at this.
yeah.
Can I go
That-
live with this? Come on,
no,
guys.
no, you better fix it. They don't see it right
Yeah.
now, so you're safe.
Yeah.
Gotta
No,
get it
that's good.
all lined
I
up.
can't believe
Yeah,
you
I know, I
slept
need to
all
spike
day
it
and
up.
just woke up.
I just got back from playing like Led Zeppelin and Deep Purple and stuff, so I'm kind of like I'm surprised I
In a
still have some
rock
voice
mode?
after all that.
I-
Yes. All right. I'm gonna go and
I don't
spruce up.
believe
I'll
you.
be right back,
It
fellas.
doesn't sound right.
What, me?
Yeah, you.
Oh,
Sure
I do
you-
a lot. Actually,
What you doing, Ryan?
I'd show
Come on.
you some, but if you're streaming right now, you'll get demonetized the second they hear Led Zeppelin.
I'd rather not.
They'll be like, "Is that a Led Zeppelin track?" Yeah. See you later.
Goodbye.
Yeah. Oh man, I got you know it's I get away with posting a little bit of like Deep Purple and Highway Star on my own channel just so that people believe me when I say that I can get really loud if I wanted to. So if they want to be like surprised with how well I behave myself on here, they can go check that out. I'm sure you can imagine if you've ever seen me on any of the other shows how much I was screaming at the
Ooh,
camera last time,
just
but not.
Hold on a second.
Yeah. Sometimes you gotta. Do they have like a limit? Like you could play like 10 seconds of a song or something?
Tea Earl Grey hot. Ooh, there we go. Look at that. It just. Very nice. Very nice.
Just give me a second. I'm gonna go get all attractive and whatnot. Not actually. I can't shave in this time, but I'm gonna brush my teeth at least because, yeah.
Yeah, because we'll see your teeth brushing.
Right. He could do it on screen. Like show everybody the proper circular technique, if that's proper. I don't know. I got an electric toothbrush now. They say I brush too hard on my gums.
What?
So yeah, they like I brush up and I push in, and they say like I'm pushing my gums up and like receding them. So they told me to get an electric brush, and it like turns off if you push too hard. It's like pressure sensitive. So now I can just kind of do it regularly, and it won't over brush or anything like that. So
okay.
it vibrates really hard actually for a brush. Like if the back end of it hits your teeth, you feel it. It's like powerful stuff.
This is
brush technology.
This is stunning. Stunning TV we're doing here.
Yeah, true that. Hey, I did want to ask you. I know we had maybe Ryan's not here, but we had got the email and said like a 10-minute opener and then 50 minutes and then 35 or something for Q&A.
Yeah.
Would you have any interest in like maybe a 12-minute opener? I don't know if I might need a little extra time.
Oh my gosh, I don't know if I can be flexible on that. No, yeah, that's fine.
I mean,
that's
if we got to eat into the open discussion or something. And I don't have like necessarily like a time limit, so I'll be. I mean, whenever you got to go, I think I should be able to hang at least.
Yeah, I think if we wrap it at 3 hours on over there, I'm gonna go back to my channel then, so I'll have another bunch of time.
Yeah, you got extra. Okay, for sure. So yeah, we can let Ryan know like maybe 11:10ish time.
Yeah,
give or take.
That totally blows out James's schedule if we go that late, because his schedule was like 2 hours, not even. So James doesn't get time estimates very good on these things.
Right. And especially like I'm just like, I personally like, if Mike, if you're debating or something, if I see you're on MDD, I'm like, gosh, just 3.5, 4, please. Come on, a few hours. I love it. I think it's informative and you have good back and forth with a lot of people. And so I think that, the longer the better, but I'm cool with that. Ryan, we were just talking about doing like 12-minute openers and then
Sure.
go till maybe about 11:10-ish.
Yeah. Yeah, sure. 11:10, whose time? How
Same.
many hours?
We're both
We're
central.
both
Yeah,
central.
So just tell me how many hours.
we're
Sorry.
we're 3.
So 3 hours. Okay,
Drizzle.
yes. Yeah. All right. Sorry. I'm in Nova Scotia, so it's almost 10 o'clock here. Don't mind
Nova
me.
Scotia.
10 o'clock.
New Scotland.
Nova.
On Nova Scotia.
You're very
Yes, sir.
east. You're
Oh,
in
yeah.
you're like the furthest east. Isn't it don't they say that for like I think it'd be I guess North America technically too, but like for America, I think the furthest south state in our country is Hawaii, and then the furthest north, east, and west
Okay.
state is Alaska. Just because it goes into it's like tomorrow in part of Alaska. So
Yeah, how did you
uh,
guys get that anyways? What's up with that? How did America get Alaska in the first
bartering.
place? It's literally
That's why Catan is
attached to
such an
us.
important game. It teaches you bartering.
Let's play the game
Which,
of
by the
Risk.
way, if y'all are trying to play sometime, just let me know.
Yeah,
Love that.
I play often. We play
You,
often.
Mike.
Oh yeah,
I
we
forgot
have
now.
all
So-
the expansions.
You do cities. What is it? Cities and Nights.
Cities and Knights,
Oh, yeah,
Seafarers.
Nice.
Yeah, we don't play
Like-
them a lot, but we have them.
What color do you use if you play Catan?
I'm
Because you
blue.
strike me as like a green guy.
I'm always blue. I'm colorblind, so the red and the black. We're almost ready to start, but like the other colors are a mess. But blue sticks out, so I'm like, all you are not blue, and I'm blue. That's all I need. So
You just know where you're at, and then everyone else is your
yeah,
comrades.
Yeah.
Commerce associates.
yes. All right, I have a couple super chats to read over here, so I'm going to mute myself that way, and you got to start soon. So
I do. Yeah, if you
Hey,
want to
could
roll
I go
through your-
first?
Sure. I
Is that
think that's
okay?
fine.
it's fine.
Thank you.
Yep. I'm all for it. There we go. Also, 12-minute timer for you.
All right, King
I might take some
Crew
moment there.
is a member at Newton. You've been
And
a
maybe
member before.
do you think you could potentially around maybe the
AC
6-minute mark
Cooper
about
is a member
halfway?
at
I kind of have
Einstein
like a
says, "Well met."
section
Thank you for that.
opener.
Stringers one
So I
says,
just
"Thank
if I could
Titicaca, it's two."
get maybe
Gotcha.
some sort of like just a nod or
Always
something.
Stringers one.
Say like
Access
halfway
Arkham
or-
says, "I'm here
Um,
for it."
I've never done a
Tuesday all
solo.
the
This is
way.
I won't
Thank
like
you.
it
Thor
actually
Rasmussen.
kind of-
Thor, such a strong name. Said, "Yeah,
I like
6
having
months
partner. I
in
just
the
like
crew."
I like the feeling
Judy
of
Bassett
having
says,
multiple
"So
people.
will
Like I
this
love
be a
the
friendly
group
debate?" It
aspect
will.
of
If you saw
working
that,
together with
Nathan's
people
a good
and
guy.
against
Nathan's a
the
good
people
guy.
too.
I'm a musician. I know what it's all about, Nathan.
MB
It's,
says,
it's
"Oh
the
yeah,
fact
more than
that if I
halfway
forget
through
what my
the
chord is
glowy
for a
thingy."
second, I'm just gonna hide behind the bass
I don't
player.
know what that is.
You know, like
Burnham
Just a quick
I know.
says,
strum,
top
but it's
three
a little.
Metallica
It's only
songs.
you only need like to be a
Master of
millimeter
Puppets,
off the
Master of
guitar,
Puppets, Master of
and,
Puppets.
and that's fine. And then you just strum that one real quick,
I don't
and
know.
then you're
There's
right
others,
back
but
to it. 'cause
that
it's
one
like,
sticks out.
bass,
That
you
one
got
gives
me.
me chills.
Drums are extra loud on that particular
Then
note.
we've got
so
PG
it's,
Tony
yeah.
for 10
Well,
Australians.
that's just
Says,
it.
"Flat Earthers
That,
don't understand the
yeah,
sorrow
no, I know
cycle.
what it's all about.
There are
It is a
sorrow
lot easier when you have
series
somebody that you can
where
bounce off
consecutive
of.
eclipses
And,
are
if you
separated
hit a
by one
wall,
sorrow
hopefully
period.
they can.
But the sorrow
pick
cycle
up where
does
you
not
left
predict
off and
when these
be,
series
compelling,
start
and
and
you're not sitting there
end.
being like, "Oh man, I got to make apologetics
Yeah,
for
and it's
what my
not based
partner
on
just
geometry."
said," which I don't think you're
Yeah.
gonna
And
have to do
Ryan
this time
says, "The
because
impossible
I mean,
Rubik's
last time your
Cube for
partner, who
membership
admittedly
makes
got
me
kicked off
uncomfortable.
before we
Keep
even got
smacking the
started last
floors."
time.
What's
Um,
impossible?
You guys were
the
having a
mixed up
great
one, yeah.
back and forth with
right.
PhD Tony, was it,
Anyway.
I think?
Tony,
Yeah,
yeah, Tony and
back,
Tom.
talk to them.
Yeah, you were
And
having a
that
good,
was nice.
yeah, you were
that's
having a
what-
great back and
yeah.
forth, and then out of nowhere,
All right,
Matthew was
guys.
just like, "You're a liar" or something, and I was like, "Oh, okay."
Yeah, right away. And I had asked him about that. I was like, man, I
Oh, yeah,
I
the
feel
other
like
audio
you
was
could have
going.
asked like,
Sorry. All right. PG Tony said, "Flat Earthers don't understand the sorrow cycles." This is a good one. There are sorrow series where consecutive eclipses are separated by one sorrow period, but the sorrow cycle does not predict when these series start and end. Well, that might come up tomorrow, that kind of stuff. I'm just going to ask him and he won't have any answers. So, all right.
You're all good, don't
are
worry.
we almost ready to launch over there?
Yeah, I just started up the old tunes, so I'm gonna make sure that it's working.
Don't see it live yet over there.
Your book is a Hobbit? No. I might have lost your book.
There, it's starting.
There we go.
I see it over there. All right.
Can I exit out of the Zoom screen? I better not.
They're all good. All right, I'll get us started up here. So 12 minutes on the floor for you there. So let me just do my big old intro there.
All right. I got my Sharpie ready to take notes.
Awesome. Welcome to Modern Day Debate, everybody. Tonight we're going to be debating. We have Nathan Pitchlumen versus McToon. It's going to be Flat Earth versus Globe Earth. And the first 12 minutes, we've decided to do 12-minute openings between the two speakers. First 12 minutes is for you, Pitchlumen, sorry. I'm used to calling you Nathan. So 12 minutes for you. Go ahead.
All right. If I could please share my screen here.
Sure thing.
Share. Do you see a do you see a PowerPoint here?
Yeah, we're looking at your PowerPoint now.
Okay, awesome. So this is the cosmological contention. This is globe versus flat. So which is it? The Earth could be flat, globular, or neither. Because the flat and globe claims are mutually exclusive, empirical science can determine falsification of at least one of these models. We should consider where the evidence most simply, without contradiction, supports which model, based on the preponderance of data collected from various fields, measures, observations, detections, and claims of logical reasoning to explain phenomenon in the model, again, without contradiction. When considering an alternative view in good faith, please consider trying to omit all of the current model's claims and take what the proposing model has to offer for this alternative contending viewpoint. We have a body of data we can draw from observations to body senses, experiments with variables to maths and predictions. With cosmology, Earth's physical shape is the primary determiner. All other phenomena are explained off of the ground, which is very measurable, so favorable for figuring. Sky data is secondary, upon the ground or around the sky, and how objects interact over the surface is tertiary, due to happening within the cosmology and not directly addressing cosmomorphology. Let us take a look at samplings from each of these levels of determinants: geomorphology, sky, objects. And this is just something, even to, I'm sure my interlocutor here would agree, and people in this community of cosmology discussion, terms like FE, what that stands for, heavily censored. So maybe we could use a term like geomorphology or something to hopefully get the word out there more, to spread it and get around the algorithms, because they are quite censoring to this topic. So we'll discuss these three. Geomorphology, when we first look out into topography of the Earth, observe what the observed world shows us. We do make observations that are planar, more suited to planar, and observations readily explained by a globe. That itself is a gnarly feat of nature. We observe events at times under natural available conditions that objects upon the surface of the water. Hold on one sec. I got this screen in the way here. Oh, wait, I can minimize it. My bad. There we go. Let's see. When we first look into our topography of the Earth, observe what empirically observed world shows us, we do make observations that are more suited to planar and observations readily explained by a globe. That itself is quite gnarly. We observe events at times under natural available conditions that reveal objects upon the surface of water to inherently impair planar. That would be
just a sec. I don't think they see Nathan's.
My apologies. Yeah, they did not see it because I did a window share. My apologies, and I looked at I've looked at the live chat. I see you guys hanging out. So sorry, Nathan. Let's continue on because I have a window share going on so everybody can see us. So sorry about that, guys.
Okay, and I don't think I had. Okay, so I should be. I'm good to keep going.
Yeah, you're good.
Okay, so the top left here, we see things that appear inherently planar to us. Likewise, we observe at times under naturally available conditions that real objects being occulted from the bottom up, inherently appearing to look like spherical curvature, which I have down here with the boat and the skyline. This alone would be impressive for either model to make claims of cause, explain and account for both observations without contradiction, as the observations themselves appear conflicted. Consider the water observations are the most physically bearing for shape, as both sides claim a characteristic of water to be that it seeks level, and water does not have topography, gradual slope, hills, jaggedness, etc. Demo and explanations, controlled variables, and recreations using them. Granting both sides their ability to recreate the apparent observation, we must see if there is a way to recreate the contrary observation with conditions we would expect nature to provide, aka real-world experiences. So on the left here, you have apparent spherical recreation on a flat surface. This would be a simulation of bottom-up disappearance. And so as you can see here, you have low objects, taller objects, medium objects, and as there's a temperature inversion, you get a bottom-up disappearing, even only leaving the tallest structures. The apparent planar recreation on a curved surface, the globe so far has failed to recreate a planar observation on a known curved surface using any claimed variables and demo the variable's ability to create the contrary natural observation. The globe has yet to substantiate the apparent planar surface seen in reality. As far as the claim to motion goes, because it's not just shape, but also motion, the globe does claim to be mathematically and philosophically equal to the flat earth claim of stillness. So the lack of motion and sensation of motionlessness are equal here. As to how of accelerative motion is not being felt or detected, that we can be addressed in the tertiary realm of discussion dealing with forces and attributes that reality exists in. Motions or motionlessness, observations, claim measures of the sky. The diametric opposition of helio and geocentered claims being 180 degrees opposite means reality can exclude one or the other through empirical demonstration. The planar Earth, currently having primary support, claims that the stars move, are approximately equidistant, and can be used for navigation in time due to having cycles. The globe claims an apparent still sky moving due to Earth rotation, different distances to different stars, and have the properties attributed to cyclical behavior. This is just a beautiful picture of our night sky. I know people zoom in on stars. I prefer this kind of open sky. It's just beautiful. Extrapolations from the abode of the above. Due to relativity claiming equality overlapping with the motion slide, direct determining of which is happening, Earth or sky moving while the other is still, is not discernible, aka the relativity trains where one is moving and the other is still, or the one is still and you are not moving, or are moving. The only motion we measure is explainable by both without contradiction, as we measure 15 degrees per hour. Planar Earth claims ether vortex, while the globe claims rotation as an absolute motion, while all other claimed globe motions are carried in space-time fabric that has the discernibility of constant linear motion, hence the trains. The display of distance. Both models clash with distance being roughly equal plane or variance globe, and can again be empirically filtered based on natural laws. The specific version of parallax used here is able to discern betwixt the two claims. Optical parallax is a phenomena that we observe when we move our observer and compare motions of close and far distances to the observer. We observe close objects boogie through the field of view fast in scale and slowness relative to the distance back, as objects farthest in the background appear to move slow. Think phone poles, tree lines behind them, and mountains off afar as you travel along the road. The poles move quickly past you at the same rate, which is key, and the trees further back move a little slower, and the distant mountains appear to hardly move at all compared to how many phone poles you have passed. Time-lapse observation. When we see a time-lapse of the sky, pictured at the right, we look at the sky, we see the stars move at the same rate. This is comparable to the uniform motion of stars, implying the same distance from the observer to the stars. This is similar to the phone poles that pass at the same rate as one travels along the distance. As we move at 15 degrees, we see in an angular field of view. We do not see more distant stars span less angular field while we turn about. This empirically shows that stars are similar in distance, otherwise they would conform to observational parallax. To cover cycles on the slide, navigation techniques and cycle configuration have been accomplished by both cosmologies. Both people can navigate and have cycle prediction. And just as a side note, if anyone is appealing to Newtonian, the lack of a shift in all the stars by 1 degree per night is not apparent, showing no orbit around the sun, because there's no 1 degree shift as we move 1 degree further along in the sun of our orbit. So object kinematics, the claim
Just
of
stepping in there,
absolute
Nathan,
motion.
just to let you know, you're past your 6-minute mark. So
Okay, all right. Thank you. The
Just in
claim
case.
of an absolute motion to a rotating globe means we can all collect data to see if rotational forces are imparted on objects as they leave Earth. The Earth is rotating, so motion is angular, therefore acceleration, and acceleration is not only felt, but observed and measured as well, needing only the ever-present Earth frame to base the motion atop. We can intake military documents, accomplishments, industry lingo, light precision measurements of interferometry, and our senses to determine if something like centrifugal force is caused by the rotation of a sphere Earth. The preponderance of evidence. So this is angular acceleration. This is a NASA document showing how they use a flat non-rotating Earth. This is a Foucault's pendulum that has not moved throughout the day. This is actually down here in the bottom left is an email from someone who shot the world's longest target, 4.4 miles. They said they did not take Coriolis into account. This is the Michelson-Morley result, and then this is centrifugal force, and then the tomatoes I'll get to with the centrifugal force. So geocentric explanations. The planet Earth needs to be accurately represented as possible to see if it offers an explanation of the worldview, meaning seasons, time zones, sunrises and sets, light patterns, circumnavigation and flights, images of globe, observed forces all need to be explained cohesively. The Earth is not a disk in space accelerating upward, having waterfall edging. Using a basic model, while it's not specifically to scale, can help conceptualize a maybe less thought of idea like zetetic astronomy. The sun and moon do not go under the Earth, they remain above. So all these are misrepresentations. And then I think here, like this is a star up close, which is still really cool, but I like the sky. But then now the UN flag map, and then the Gleason map, and then this is just something to help get an idea of how things might work. Natural workings of the planet Earth, several claims, demos, examples, and explanations. Seasons are only are explained by the sun moving between the tropic circles, Cancer and Capricorn. These are only locations that the sun can appear overhead at zenith, 90 degrees perpendicular. There are more time zones in the southern hemisphere than in the north, with the equator having 24 to match the 1 hour distance of sun travel in a day. There are some 30 time zones plus time zones in the south. Tropic circles, close small circles in the summer, distant large circles in the winter, a less direct, more distant sun passing by faster, so less exposure to light throughout the day, all cooling for a winter time. This matches the solar analemma. A globe would provide equal loops to the analemma, so long as the claim of the Earth orbit is planar and that we're not on an ecliptic. I think it's just the Earth that's tilted. But you have the analemma here to match the smaller circles in the north and then the larger circles as it loops on the outside. Sunrise and set. Sunrise and set have been shown on a flat surface using atmospheric variables like magnification and temperature variance to show how sun can appear to rise and set while keeping the same size and shape. So these are actually globe scientists who say that the atmosphere acts like a lens. This was during the Chicago skyline. Chicago City being viewed from Michigan, which defies the curvature rate of globe. And then this here shows using lensing that you can get a sun at rise and then have it set further back here, and it will still appear the same size. This is just something talking about refraction here. Sun casting light. Light can only travel so far from the source of emission, attenuation of light, and the light patterning of a source like time and day, it's supposed to be time and date, has been recreated using a dome to simulate the firmament. So this is just a light pattern here, and then this is a very crude example, but it shows how you can get
30 seconds.
These lighting effects. Circumnavigation, we can circumnavigate, but anytime they try to go to the South Pole, they always bank. They never go straight through north, straight through to south, show a compass needle flip especially, and then go back to north. Flight routes, we have an emergency flight from Chicago to Dohan, and it stopped in Moscow, but despite closer emergency flight routes being more available. Images of Earth, you have Photoshop because it has to be. NASA using flat Earth. Sizes of the continents are extremely different. This is a water ball. And then we use flat maps, which are able to have a key and scale, and we use them to travel. And then duplication. And then this is the force, which, am I out of time here?
Yeah, you did run out of time, unfortunately.
Okay,
so.
all right. Well, yeah, that is all. And then, yeah, okay, thank you very much. That was, okay, anyway, yeah, I'll stop there and here.
No worries. If there's anything you missed, I have no problem. If you want to bring it back up and come full circle, that's no problem. So let's just get back to our main screen here. So welcome everybody to Modern Day Debate. If it's your first time here, hit the like button, share this out in those spaces you like having these discussions. We're having a lot of fun over here. We're discussing flat Earth versus globe Earth. You just heard Nathan, and I'm sorry to anybody who was seeing my screen for a second there. I'm doing a window capture so that we can see the speakers while they're doing their presentations because we had so many screen shares last debate. So over to you, McToon. Thank you so much for being here.
All right. I'm sharing my screen.
Sharing is caring.
Let me know when you can see it.
Yep, we're up and running.
All right. Well, my beginning will be quite similar. So how should we determine the shape of the Earth? In a series of lectures by Richard Feynman, he described the key to science. So I want to make sure that this audio comes through. Let me know if you're getting it, Ryan.
First we guess it.
Yep.
Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature. or we say compared to experiment or experience, compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science.
To actually establish the shape of the Earth, it requires computing the consequences based on the hypothesized geometry, including applying the laws of physics. Ignore the laws of physics and you're not computing the consequences. Then you test these computations by comparing them to observations. And if the computations match, then you have evidence that your hypothesis is correct. Nothing is proven, but it supports your hypothesis. And if the observations don't match, then the hypothesis is wrong. It is falsified. But flat earthers fail to do these in two ways mainly. First is by getting the globe computations wrong. When you ignore confounding variables, which is super common, you're strawmanning the globe. And number two, by never providing computations for flat earth. If you're unable to compute the consequences for flat earth, you showed up at the horse race without a horse. You're not able to even begin doing science.
Sorry to cut you off, Mike. Can you give your mic a little more love?
No.
You're just coming in a little low.
I don't know if I can.
Okay, I'll turn you up. Don't worry. Just carry on.
Okay. All right. As a contrast to the standard flat earth method, I'll use both globe and flat earth to compute the consequences of each hypothesis and compare them to observations. I'll use both flat and globe to predict the sunset time for my location today, February 20, 2024 in Minneapolis, Minnesota. To predict for the globe, I used NOAA's or NOAA's SolCalc website, which is on the screen there, to predict the sunrise or the sunset for the globe. NOAA provides a spreadsheet with the formulas for the calculations on that webpage there, if anybody wants to verify how the consequences were computed. So I calculated the sunset time for today, February 12, from Minneapolis. The globe predicted sunset time is 5:47 p.m. And I was at a Thai restaurant in Richfield at 5:47 p.m. And there's the picture out the window. The sun was setting. So I personally observed it to set at 5:47 p.m. Globe confirmed. The flat earth, well, that's harder. I couldn't find any resources for predicting the sunset time using flat earth, so I computed the consequences myself. To compute the sunset time for flat earth, we need to determine when the sun will cross the horizon according to flat earth. This is done by applying the laws of perspective. First, we need the elevation of the sun over flat earth. Some flat earthers give values for the height of the sun. Not very common, but some have. Samuel Rowbottom said less than 4,000 miles. Wilbur Voliva claimed 3,000 miles. Alexander Gleason, who popularized the most commonly cited flat earth map, but it's just an azimuthal equidistant projection from the globe. Anyway, in his book, he claimed the elevation of the sun to be 1,725 nautical miles or 1985 statute miles. And Eric Dubay even gives a value himself.
Both the sun and moon figure to be only about 32 miles in diameter and approximately 3,000 miles away.
But there's some variation there, so I measured it myself on both equinoxes from 45 degrees north latitude, where I live in Minneapolis, hypothesizing flat earth, and got 3,105 miles. Details of that are on my website if you want to see. I'll start with this number. And if any flat earthers have a different value with a more rigorous method than mine, I will be glad to use it, but I have never been given one. Sometimes, I keep asking, but flat earthers rarely present any method, anything that's testable to determine the elevation of the sun or anything else over their own flat earth. Why not, guys? Give it a shot. Just predict it. Get to work. Roll up your sleeves. Anyway, I did it for you. Once you have the height of the sun, you need the distance from the observer to the subsolar point on flat Earth. This would be easy to obtain from a real map. However, Gleason's map doesn't have a scale. There are no flat Earth maps with scales. But we do have this from Gleason's map. This is the thing that sometimes they call a scale. It's not a scale. You cannot take that and lay it on the map to determine distances. But the part I circled there states very clearly that there's 60 nautical miles to the degree, and that is definitely true for lines of latitude. I completely agree with it there. That is a fundamental part of celestial navigation. So I'll use that happily. But when we do that, then we can shoehorn, you can sort of shoehorn the latitude and longitude into being a polar coordinate system. I won't go over the details. It's some algebra, high school algebra. Then we can apply the polar distance formula to get the distance between any 2 points. Again, flat earthers, I'm computing the consequences of your claims. If you think this is wrong, provide the right method. I'm simply applying geometry to flat Earth's claims. The subsolar point of the sun is the position on the Earth directly below the sun. It's well known for any moment of the year. At 5:47 p.m. Central Time today, the subsolar point was 10.8 degrees south and 173.7 degrees east. This is the ocean north of New Zealand. And applying the polar distance formula, we get a distance of 7,788 miles for flat Earth. Now we can fill in the distances and apply perspective. 3,105 miles high for the sun and 7,788 miles across the surface. To apply perspective, we simply solve the triangle. Then get the angle of elevation for the sun. Right there. This is, when you solve the triangle, 21.7 degrees above the horizon. That's the flat Earth prediction for 5:47 p.m. today as what we should see from Minneapolis. But observations do not match, because in reality, the sun was setting at that moment. Flat Earth falsified. Again, flat earthers, I'm simply applying geometry. If you think it's wrong, provide the right method. I don't want to hear it's wrong and then have nothing to follow up with it. Show the right method. Do you think there's some sort of optical effect at play? Provide the empirical evidence for these effects and the method to compute the consequences. And I'll be happy to update my method. Catchphrases and word salad are not a substitute for computing the consequences of your claims. There you go.
All right. Well, you still had some time on the clock there, so we'll just put this back to our regular screen. We are going to put it into open discussion there. So if you just got here and you're just hanging out, once again, hit the like button. We're going to be doing a Q&A at the end of the debate. And you know what? For funsies, I'm going to pop a Q&A in there right now. So if you're hanging out in the live chat at Modern Day Debate, we'll put up the poll there and you can vote. And we're going to put it into open discussion. So over to you, Pitch Lumen. And yeah, let's have fun.
Yeah, let's yeah, thank you, Mike, for that. I Feynman with the keys to science, compare calculations. I guess real quick, Mike, could you clarify compute the consequences for me?
Compute the consequences would be in most instances mean doing some math. You would need to now it doesn't absolutely always have to be that, but you can for example, if you are hypothesizing that a benzene ring is, or a six carbons in benzene is in a ring shape. So computing the consequences of that would be some way of then,
like measuring bond angles.
Yeah, things like
of
that.
the ring, what the angles would be.
Yeah. So that would be, computing the consequences. But if the sun is hovering over flat Earth, then computing the consequences of that would be, well, at this time of day, what angle should the sun be at for this location? When should it set? What is its angular size to be? These are all computations that we can do based on physical objects and known laws of physics and geometry.
Okay. So if I may point out here, so in your diagrams, it had shown geometry, which I do agree with that the math is correct. If you measure the height of your object and then the length of the shadow that it casts and the angle, you can calculate the height. I would like to point out as potentially some scrutiny to the how well that mathematics compares to reality, as far as trying to apply it. So the claim of a flat Earth has an atmosphere, which can have distortion, refraction, cause a shift in apparent position. There is also claimed to be a firmament, at least that I will claim a firmament above us. So it is a structure that is a different medium from the air, especially if the air is very thin up there, and then it suddenly hits like a dense medium. And I'm actually not sure how far embedded into the firmament the sun might be. 3 feet or 50 feet or 100? Is it on the other side of the firmament, and maybe the water up there is another medium change? So I think that those would, in the geometry you showed, I think you provided straight lines, which is accurate for geometry, but I think that those apparent distortions, the refraction to light, would cause a bend of the light. So maybe those triangles are not necessarily ascribable to reality. Because I myself.
So how would, so then my question is then let's go through it. What's the correct way to do that then?
So I'm not sure, because I don't know how to correctly try to measure the sun as far as its height. Unless, like, I can't think of anything. Taking a tape measure up to the firmament, even if we say we touch the top of a tape measure to the firmament and then dropped it all the way down to the ground with a really long tape measure, whatever that height is, if the sun is behind that glass casing, we can't put our measurement up into there and determine that physical, tangible measuring itself. So I don't know of any way.
Does glass reflect radar? It does. It's a trick question. Of course it does. Why, when we point radar up to the sky, does it not bounce and show up as something there at some reasonable elevation for what the firmament would be, unless we point it at the moon? When we point it at the moon, then we do get a bounce back of that radar, and the distance is a very particular distance based on the amount of time that it takes. But everywhere else we don't get that. Well, not everywhere else, because when we point it at Venus, we get it back, or at the sun we get. Anyway, if we don't point it at the planets, we don't get a reflection. So why is the firmament, which you said is glass, not reflecting radar?
Glass. Maybe I should say, I might have misspoken there. I guess I could say like crystalline structure, or it's like a molten glass. I don't know the exact chemical makeup of
things that would reflect radar.
Well, if it's a chemical crystalline structure that we are not really too familiar with, it could penetrate that, and then it could hit objects, like if the sun and moon and luminaries have some sort of reflective property.
Okay, so how do we do science on that then? Because this is just a lot of conjecture. Conjecture isn't science. So how do we empirically verify these things? Has it been done?
Well, there have been things, I believe, like Dominic and fishbowl operations, where there were things sent up into the air. And I believe that the Van Allen belts are something that is claimed to inhibit us getting out of low Earth orbit. And then you have like Bill Nye, who says we're in a closed system. I think that there are things. The sky. I will.
Let me address a couple things.
Yes.
The Operation Fishbowl and Dominic, those were not attempting to hit the firmament. They didn't go nearly as high as the claims of the firmament typically are, though the claims of how high the firmament are all over the place. They vary even more than the couple examples I gave of people's sloppy guesses at the height of the sun. I think there were tens of miles, not hundreds of miles up in those things. We can get through the Van Allen belts, and the quote that you're thinking of is specifically about the computer systems and navigation systems in the Artemis missions. So you need to certify any system that people ride in, before people ride in it, that it won't have an error in it. So when you're that particular quote, which was a kind of a fluffy thing made for end users, or popular consumption, not a scientific description of what was going on,
to promote space travel.
Yeah, it taking that as a hard scientific statement isn't the right thing. That's not its intention. So the Van Allen belts, nobody has trouble getting through it. They're not that dangerous to people. Shielding against it for people is pretty easy. So you do.
They were supposed to have had shielding back when we went to the moon, allegedly.
Yeah,
there was a shielding in place. I think one of the astronauts said they didn't know about the Van Allen radiation, so they didn't. I don't think they had necessarily prepped for it on that journey. But if they did go through it and come back without any shielding or even with, then it would show that
they did have shielding.
Okay.
They did have shielding.
They did have shielding.
They were inside of a craft. That craft is the shielding. It was metal. How do you shield from that? Thin pieces of paper will shield you well against alpha particles. Beta particles, you need a little bit more, and metal is just fine. So,
okay.
Yeah.
All right. Well, and that's so like with things of the sky, like distance to the luminaries or something like that, that is something that I will readily admit that I don't have precise measurements, the size, the shape. I think that you would maybe be assuming distance or size and then calculating based off of that, because if you don't know the size, you don't know the distance, or if you don't know the distance, you don't know the size. I think that
I went through the math. No part of the math used the size.
Okay.
So you don't need to know the size. And Nathan, I know you're not bad at math. I know that you followed along with that.
It's tough though,
right?
Yeah.
So,
no, I did follow. I would. That's part of what, like with this sky, with claims like that, I don't know exactly the specifics of the sky, which is why I would prefer to focus on the ground, because I think that that's a little more testable, and like airplanes and stuff I think could be more known, but that's what I was I didn't want to bring that test to the site. Oh, and then with the sunset too, by the way, that Thai restaurant is good.
Have you been there?
Yeah.
Joy's Thai restaurant. I haven't been there for a long time, but yeah, they did not ask how spicy I wanted it, which usually in Minnesota means it's going to be not spicy, but it was.
Yeah, their one's really still like a 4, so the place is heat. But
this is where we've gone, right? That's great.
Yeah. I am curious, even too, like with the sunset, you do have something like refraction that can be at sunrise, and that even like I think the global claim sometimes the sun is maybe set before it's actually set.
Actually, I have a thing I can show if you don't mind on refraction in the air. Can I share that?
It's showing.
Yeah. All right. Hold on. I need to switch on my system.
You're good to go.
So here is Batman there. He's looking at a building, and this is no refraction. The light goes straight. And so that light, if we take that beam of light that started there at the top of the building, and then we add some refraction, you can see that beam of light won't get to Batman's eyes. It'll, hit the ground somewhere before him. So then if we look at another beam of light that came out from that point, because the light emits in all directions from the surface, unless it's got something special going on. That light that initially would have gone over Batman's head is bent down. That's what Batman sees. And to Batman, he sees it at an apparent higher position. So this is downward refraction. And you mentioned that. You had a picture of downward refraction in your presentation. So downward refraction causes distant objects to appear higher. I have a significant amount of documentation on that on my website, mctoon.net/refraction. So I'm not just saying this blindly, but I'd like to see, could you bring up your thing of the Chicago skyline? Can you bring that up?
Yeah.
Because I have that thing from Skiba. I have it. It's on the floor behind me here. And I want to point out something that's important.
This here?
That's the one. Yep. So now look at on the left side there. You've got the demonstration done by the scientists, as you said. I think it's a teacher somewhere. And you see there's a magnifying glass there. You see that ring there on the other side of the table?
Yep. I should be able to, if you can see my mouse, this here.
Yep. So you're looking through the top of the magnifying glass, and the top of the magnifying glass will cause light to bend down because of the way that it's shaped. Right? Then on the right side there, you don't see it, but that box there on the bottom there, that bottom of the 3 there, you don't really see it in this particular picture, but Skiba is using the bottom part of the magnifying glass there. And the bottom part of the magnifying glass will cause light to bend up, not down. So this is a straw man of the flat model, or a straw man of how refraction actually works, because refraction, you need to use the other part of it. And I don't have it handy, but I actually did the same thing, and I moved the magnifying glass down because I've got a table with leaves in it, and I dropped it down a little bit so that only the top part, just like in that demonstration there on the left side, so only the top part of the magnifying glass is being used, and it causes it to set, or it causes it to be a little bit higher. So it sets a little later, but it's still, actually it doesn't set because it's over a flat table. So it makes it higher as it.
But it still appears to go down. It just is further back.
It never set when you do it. When you refract light the correct way, it doesn't set.
So how I would respond to that would be if you do use another portion of the lens that does cause it to require to go further away to get that apparent of setting, you also have, when we look out to the sun, for example, for a sunrise or sunset, we also have the ground itself and the sky converging on a point where that is going to create a vanishing line and things, and so you can hide information, visual information beyond that line.
And I'm going to need empirical evidence supporting that claim. I've heard that claim many times, but never seen any evidence for it. What you described, though, is an application of perspective. Things get smaller as they get farther away, but the sun can never be close to the horizon on flat Earth. The example here that I used for Minneapolis was over 21 degrees in elevation. Nowhere near. Not even close.
It was 21 degrees based on an assumed height and without any medium change.
A measured height. I measured the height, hypothesizing flat Earth, so not assumed.
Yeah. It was measured 21 degrees, but there's medium and atmosphere that it's traveling through, plus any firmament structure that it would be.
I'm just going with empirical evidence, though. There's no empirical evidence for the firmament. It's just an empty claim, not science. It's just a religious belief, right? You don't have evidence for it.
That is, I do not have a piece of firmament in my hand, which I think would.
That's not what I wouldn't. No, I'm not expecting that. Right, I said radar. I mean, there's many ways to confirm that something exists other than just going there and chipping off a piece of it.
Yes. Right? Well, so you say with perspective, if you have perspective, you get something like the objects that are further away, they will shrink, and then there is also a change in apparent size. And that's actually one thing magnification does help.
You said the same thing twice. They shrink and they get smaller, right? That's the same thing. They do get smaller, and solving triangles is how we can resolve those things. That's how you apply perspective. Solve triangles.
Yes, they have an apparent size, and then as you go further away, if you have refraction bending the light downward, the sun won't have to go as far away because it will be being bent down. So that will cause the light eventually to not reach Batman's eyes for the sun, and it will hit the ground instead and run.
But the light emits in all directions from the sun, so you'll still see it. It's just the light that would have otherwise, without refraction, gone over Batman's head.
Well, that's where I think you can get into things like the optical effects of light with a dome, where you can get light to, like, this here is a light source, and it's going further out towards what would this be, South America over here, but it's not even, it's hardly going past the North Pole here. So there does appear to be, and this is a very crude example, but I think if there is an all wise, all intelligent, all knowledgeable creator, they would be able to set up a system so well engineered that it allows us to perceive a sun that can keep it's at the
that's
right
just-
distance and angle to the material.
Dude, that's a hypothesis that you can't even begin to think about testing. But here's my question for this one. My response, that acrylic dome that you have there, it has an index of refraction of about 1.5, and the light is in an area of air, which has an index of refraction of about 1.0. In reality, the air above us is not an index of refraction of 1.5. It's 1.0. And if there is your hypothesized dome, then it has the index of refraction of 1.5 or something more. So you actually have it inverted. This example is the opposite of what your claim actually is.
Light would be bending upwards because of the dome. Because this dome is showing a lighting pattern that matches
it is,
a time
but
and date rendering.
Not quite. But let's imagine, grant you for a second the imagination that it did match somehow time and date. It won't match the direction that the sun appears to come from. Well, that won't work. But let's ignore that for a second. The problem is that air does not have an index of refraction of 1.5, and that's what your example here is using. And it's using an index of refraction of 1.0 outside the air portion of it. So you've swapped it. So what you need to do to test to see if your hypothesis could even begin to work is to put air on the inside and on the outside have some sort of a structure, your dome stand-in or analog.
Some sort of crystalline and maybe water behind it.
Yeah, so you've done the opposite. So this isn't evidence for flat Earth doing light patterns as you hope it does, because it's the wrong materials, the wrong index of refraction.
Yeah, that would make sense. So this would have to be something that would be recreated in an inverse, having a pocket of air inside the dome, and then different mediums outside. Right?
Yeah.
Okay. Well, that'll be something that I will have to I'll have to look into that. Do you mind if I bring it to the ground?
Okay.
So let's go, let me see here real quick. This here is just an image of a bay where you can see it's the same day, but at sometimes you can see the so much of the horizon, and then at other times more is exposed. And so I'm curious, like if we have these different days where there's different amounts of refraction or the temperature is different, how do we get these observations that appear to have multiple data points that if you line them up, they're linear? Is there any demonstration that you're aware of that can show a surface that is curved, that can recreate using refraction, using lensing, any variables that can create a known curved surface to appear planar, like beyond mathematics? I'm talking like a demonstration.
Yeah. So there is, I'm not exactly remembering where it is, but he's on Discord a lot, and somebody in the chat can maybe help me remember his name. He's super nice guy. He did a salt or sugar in a tank of water, and he created he used a curved piece of metal, I think, and he suspended it in the middle of the tank. From the side, you can see that it's curved. And then, but from the end to end, you look through it and it appears flat. No, it's not doofus. Man, something.
So you're looking the long way. You're looking
Jesse,
out
Path
towards
of
the
Light.
horizon.
Yes. I'll see if I can find it. Yeah.
Yes, if you could please, because that is something that I hope makes sense. Like here, where like with one of the things that biblical earthers get a lot, or flippers get a lot, is like bottom up disappearance. And this here is a flat surface. At least it's a floor. It's flat enough, and I'm sure carpenters and everything would talk about that. It's flat enough. And these objects are certainly large enough to be to scale. And this is showing that the flat Earth can actually demonstrate hiding objects that would be bigger and harder to hide.
Yeah. So I'll ask, what is the conditions that is being simulated there? Like, what is the lapse rate that's being simulated?
The exact lapse rate I don't have. I will say that it is using the variable of temperature variation, because over something like water and land, water has a different heat specificity. So
hold on. Back it up a little bit here. Just back up 2 sentences and say it again.
The water has a higher heat specificity than land. So water
what does that mean? What does that mean?
Water stores heat. It takes more energy to heat water up than it does to heat land up.
Okay,
so
I get. Okay,
there will be.
It's called specific heat.
Yeah,
you're wit sitting on me here. It's not specificity.
I don't mean I was taught heat specificity as the term for it.
Are you serious?
Well,
okay. Well,
yeah, 4.148 or something like that.
It's specific heat. 4.
Yeah, heat.
Yeah, water is the definition.
Yeah,
it's the top.
But yeah, specific heat. Water takes a lot of energy to heat up, and so the point of it is that temperature would be different over water than over air than over land. So there are a mixture of temperatures, and you can have hot and cold, and so that can cause.
That's why I asked
this.
What is this? What is this simulating? What is the actual index of refraction gradient that this used for this demonstration?
The index of refraction, I'm not sure that this is just showing that the claim of changes of temperature is enough to cause a hiding of the bottoms of buildings, of shorter buildings, and to cause us to reveal something that would be similar to only seeing the top portion of tall buildings or the bottom of the top sails and mast of a boat. This shows that there's a variable that we can use and put to.
I asked you because I didn't know if you knew, but you don't. That's fine. In order to cause this type of effect, you need to have a specific index of refraction gradient, or a lapse rate, as it's sometimes called, where you have an index of refraction that's low near the ground and high as you go up, which is the opposite of what we see in reality almost all the time. So this is showing the opposite. The refraction.
Can you say that? Can you say that one more time?
Yeah, it's because it's inverted. So in order to cause things to appear to get blocked by a flat surface, you need an index of refraction gradient where the index of refraction is low near the ground and increasing as it goes up. But that's not a stable position, because generally that means that you have denser air higher than lower, and they want to reverse then. So you'll get this churning effect, and they swirl around and things like that. It's unstable. Where it is stable to have a a denser air with a higher index of refraction at the bottom, and less dense air as you go up, which has a lower index of refraction.
So then, if I may ask, going back to the planar recreation, you had mentioned that there was a tank with salt water that was used to give an appearance of linear, despite the metal itself being curved.
Yes.
So isn't that going from a low density medium into a very high density medium into a medium density medium, and then back through the glass on the other end?
It's low density at the as you go up, so it's highest density at the bottom. But this demonstration you have here, well, it's not on the screen anymore, but the demonstration you had that one there, yeah, that would require the inverse.
So wouldn't this, if the person is looking through the fish tank, aren't they they're looking through a low density and they're looking horizontally as opposed to considering like the changes as you go vertical. They're looking horizontal and they are looking through themselves. They're looking through low density, extreme high density, and then the density changes as you go through salt water to get an apparent flat look to something. Because this, like these examples here are all through air. Like these are all through air, and then
Yeah.
this here is through air as well. And
Yeah. Well,
so
it's
that
it's simulated. It's simulated.
Yeah, it's an attempt to try to isolate or say, hey, we claim a variable, and then we want to try to show can it. And I think that's the point of this demonstration, is just to show that it is possible to use natural conditions. There's no blaster furnace or extreme freezer or anything like that. This is using natural conditions to show that it is actually possible to get the bottom up disappearance. And I am curious as well, because I know people have made measurements and observations, say just across lakes, large lakes or bodies of water, and they've done it at freshwater, saltwater lakes, bays, and everything, various distances, long and short, relatively speaking.
Okay. I have it ready if you want to see.
Yes. I will stop sharing, but we see these various FARD sightings in various conditions, and I'm just there is actually something that I'll pull up once you're done, but it has to do with in chemistry. I learned for refraction that you have your standard temperature and pressure that you make a measurement at, 20 degrees standard pressure, atmospheric pressure. And if you add 1 degree Celsius to that measure, to the conditions, you have to take your measured refractive index, and then you have to add 0.0004. And if you go colder than 20 degrees for every 1 degree Celsius, you have to subtract 0.0004. So the hot and cold temperatures actually change your refractive index, and one will bend light further or less than the other. And we do see far in both conditions of cold and hot, despite them having opposite bending effects on light. And I'll show the document after that. But
Well,
go ahead.
Yeah, here's the video. Are you getting this, Ryan?
Yeah, we got it. And if you're hanging out in the live chat right now, we still got, we had a planned 20 minutes of open discussion before we move into the Q&A. So if you haven't gotten a question in there's tons of questions. So once we move into that, I think we're going to be here for quite some time, gentlemen. So just brace for impact.
Hey, with Mike, it's
glad?
never long enough. Who doesn't want to hear him? This is science. This is actual contention. Mike is awesome, y'all.
You guys are awesome. Honestly, this has been one of my favorite ones to host, because I get to sit here and just listen to you guys chit chat. And aren't you guys glad though? Let me know in the live chat if you're happy that you can see the speakers on screen. I know I messed it up at first, and you could see me typing in the live chat. Ha ha ha, Ryan's silly. But isn't it nice that we can see our speakers while they're doing the screen presentations? Because there has been a few of them. So hit the like button. Over to you, McToon. Without further ado.
All right. So there you see, I'm going to play it. You'll see that bar in the water is curved right there. And he's showing now the laser going right over the bar, and the laser matching the curve of the bar. He's got like some little topography that he added. And the laser's actually bending more than that bar. And then he'll show us from the end here. He gets down closer to it, and you can see when you get right down to the end here, that bar, which is curved in reality, looks straight. So there you go, right there. So that bar looks straight, which we know is curved in reality, and that's what bending downward of light causes, and that's again, the index of refraction is highest at the bottom, which is similar. It's the analog to cold air over water, for example. And then as it goes up, the index of refraction reduces, which would be similar to the air over water getting slightly warmer as it goes up. So there's the.
Would you be able to back that up a little bit? And also, if you could send this to me, or I'll probably watch this again, because this is something definitely be needed to look at. Just curious too about those nodes that he has sticking up on the metal. Those are
It's some sort of it's like a clay that's meant to simulate topography, like
and
hills or mountains.
he's shining the laser by the clay.
Yes, by it.
Okay. And then I just noticed there at the beginning, so it kind of looks like that laser is entering into the glass straight.
Yeah, it's coming into the glass orthogonal.
Okay, so
Yeah.
the laser is level and then it goes upwards with the curvature. So then
Yeah,
I
all
would
right.
ask
So
is
you could be right there. The laser might be not quite orthogonal, so that it matches the angle of the left side of that bar.
okay.
Yeah.
And I'm curious too, because this is showing I would wonder what the observation would be if you because like if we're talking about like the four lights experiment or those observation or those windmill bases, that would be on a globe you would be looking tangent out, and then they would be dropping down, whereas this bar is kind of going with a hump. And so I'm curious if this would have the same effects uh going tangent as opposed to going riding the curve, the curvature of the I imagine it would, because this appears a little more um severe. So the light is going, it goes, once it enters into the salt water, it travels upward. And then once it gets to about that halfway point, that's where it will start to then bend due to refraction.
As soon as when it's in the water, then it's going to begin bending due to the index of refraction gradient.
So how does the light go upwards to get up the curve?
The angle that the light is outside the tank, it's slightly bent up. So like I said, I misspoke when I said it's orthogonal to the tank. It's not. It's tipped up a little bit.
It goes, which could maybe, I don't know if that could have something to do with reflection. As far as the angle you receive is the angle you reflect.
Yeah, once it's past the glass or whatever the tank is made out of, then its effect on the path of light is done. It can't affect it later on. It's already gone through it.
It could maybe tweak the initial entrance into the medium, though, into the tank.
It certainly, it very likely does, because it's not coming in orthogonal. It's got a little bit of an upward angle to it. So like the cover of the Dark Side of the Moon album by Pink Floyd. Not as severe, because it's because the glass is parallel. Both sides are parallel. It's not angled like on that album cover.
Yeah.
And prisms specifically are chosen because they have a high index of refraction. And fish tanks, it's not super desirable to have a high index of refraction. Of course, strength is more important, but when they're parallel pane, when the pane of glass is parallel, it doesn't have that same effect like on the Dark Side of the Moon cover. But it does affect it. It is going to come in. It's going to refract towards the normal, and then when it comes out, it's going to refract toward the normal again.
Okay. So that would be refracting towards. So it goes, okay, so it goes up, and this will be, I'm gonna have to look into, because the laser does appear, the spacing of the laser from the metal, it does look to be riding the contour of that metal.
Yeah.
Do you mind if I, real quick, let me pull this up. Could I just show
Sure, if you can end your screen share there, McToon.
Yeah, there you go.
There you go. Over to you, Nathan, when you're ready.
All right. I'm just trying to find the here it is.
That's my chance. Smash the like.
Yeah.
Yeah. If you're watching on McToons too, I mean, hey, why not? I think you're still streaming over there. Join over here and for a second, hit the like, join in the polls.
Like it if you like it, right?
While we're on this little aside here, N-99% God wants to debate me, I would mention it in the Modern Day Debate chat, but I still cannot chat there, Ryan.
Don't look at me. I'll figure this out. I
All right.
swear. I'm gonna
You got-
figure this out.
Get this dude in. Get him in.
I'm gonna figure that out. But yeah, honestly, I just gave that individual mine and James's email, so you can email me at bc.adt@outlook.com or james@moderndaydebate@gmail.com if you'd like to participate at Modern Day Debates. I know James is pretty busy writing his thing right now, so if you want to get a hold of me, that's cool. If you want to get a hold of James, you might be waiting a little bit, but then you'll be getting to talk to the top-notch boss there. So. Let's carry on, fellas. You
Yeah.
got your
Okay.
screen share ready?
Yep. Is it? You see this here? This paper?
I gotcha.
Okay, so yeah, this is talking about the index of refraction. So this talks about the velocity of light. It's not constant in all medium. The bending of a beam of light as it passes through the interference of two different media is a consequence of the variation. So it talks a little bit about how to calculate the index of refraction. And so this here is actually the standard temperature for measurement of the refractive index is 20 degrees Celsius. If the temperature deviates from this, a correction of 0.0004 degrees per degree above 20 must be added, or a correction of the same amount must be subtracted from the value read directly from the refractometer. So this is talking, and then it gives an example here about how you would alter the measurement. And so this actually I would put in line with, for example, the four lights observation was done in winter, and then actually even in the this here. So this is winter. This is a frozen lake. And then this here.
There you go.
This
You're not
here
showing yet. It says that you're starting. There you go. It's ready.
Okay. So this here, the bases of these windmills would be in a warmer weather condition, and then these here would be in a colder weather condition because this is a frozen lake. So this is showing that despite temperature's influence on light, bending it in alternate directions, changing the refractive index that we actually measure, we have to apply correction. We are able to see very far despite the weather conditions. And then this can go into things like, I think it's the Mount Canigou, the extremely long distance observations that we are able to make despite the claim of a globe, which, and one thing to consider about the planar Earth or the globe Earth, planet Earth, is and this might be a false sense of illusion of knowledge or something. I don't know how to, the words there. But with the globe, we're claimed that we know we know the distance of the sun, the size of the moon, how far away stars are, and what they're made of. So there's a lot of claim to knowledges of the sky and these sorts of things. But I think that there's a lot that we are still trying to understand. But we do, the claim of the globe is that the Earth has a given radius and a given curvature rate. And I know the 8 inches per mile squared is an approximation that is like up to 1% off. I think that's like 1,000.
8 inches per mile squared is perfectly fine when used in the right method. But flat earthers
often
often
it doesn't factor
use
in observer height, right?
It's not a method to determine the amount of bottom-up obstruction. It's a fine method to measure or to predict linear drop from a horizontal tangent. But a lot of people say it's the curvature rate. The curvature rate is not. The curvature rate is 1 degree per 69 miles, or 1 degree per 60 nautical miles. That is the curvature rate. 8 inches per mile.
8 inches per mile of Earth traversed would curve, but that's you would basically be resetting your.
It's a drop. That's all that's giving you is a drop from a horizontal tangent, and I've used that in several things. Jaron used it in his experiment in the movie, and it's the correct formula. In that instance, he still made an error in his math, but it's the correct formula. So you need to use the correct formula correctly. He almost got it.
Okay. And actually, real quick, I would like to say this too, hopefully to maybe get a little bit of heat off of Jaron. But if I might just real quick address that movie, the documentary, or what some people call a mockumentary, Behind the Curve. Jaron had said, and I believe there are some globe defenders, maybe people who are not too fond of the flat Earth idea as well. People have contacted those there. And people have on both sides said that that night nothing was shown. And Jaron actually, I believe some people made some money or something off of his interesting quotes, and he did not. And so I would just like to point out that that documentary, there was things about the directors and them not being quite honest with him or telling him all of their works before he agreed to do that. And then there was also like they had wanted to make it a balanced representation until I believe a kid rose up at a convention and had said that some of the flat earth stuff was kind of making sense. So they decided this is a little bit serious. So we should kind of slant the message a little bit because, yeah, I think that both parties left that night with that experiment with Jaron that they had said, yeah, it's not really conclusive. We've gotten results kind of showing both. So I just kind of wanted to state that as well. And we can talk about like the measurements of the 50 degrees.
I
just want to throw that
out. I've analyzed what he did in a lot of detail. I did a video on it a while ago. And someday Jaron might be ready to talk about it, but he's not ready yet. All right. I have something to show you. You were talking about frozen lake.
Yeah.
There is empirically confirmed measurements of the effects of the index of refraction change. So, and the biggest driver of it in the low atmosphere is temperature. And over water has a high heat index.
Specific heat.
Or specific. I didn't want to say it wrong. I'm like, darn it, you got me. Specific heat. So it has a high specific heat. So it changes temperature during the day slowly. So in the afternoon, when the air has had a lot of time to warm up, the water is still much cooler than the air. So on a sunny day, the lapse rate is maximized in the afternoon and it peaks after sunset. Cold lakes, and you live in Minnesota like I do, and maybe you've walked on a lake like I have, you can be comfortable. You could have your coat unzipped, you could have your hat off, and your feet are dying because they're so cold when you're walking on a lake, because that ice is not going to melt. It's going to be at freezing temperature. It just absorbs all of the heat. So there's a very high index of refraction gradient, or temperature gradient first, above a lake.
Water does, just as a fun fact, water does have some interesting freezing behaviors around the 0 degrees Celsius mark. There, like 0 to 4. It's incredible.
It is very unique. If water did not do that, life probably could not exist because lakes would freeze bottom up instead of top down. So anyway, and every year in the spring, we get to see that in lakes. You'll be walking along, you'll see a lake, it's frozen, and then the next day, completely gone, because the whole thing inverts. It's pretty cool. Okay, so the index of refraction gradient, or the lapse rate of 1, this is the key number, empirically confirmed, 1 degree per 10 meters. Is the number that is an important number. So what happens is, as we saw, that
10 meters raise in elevation.
Vertical, yes. So that beam of light, that laser that we saw, has a curve to it, and that curve has a radius. In the air, the radius of that curve is equal to the radius of the Earth when the temperature gradient is 1 degree over 10 meters vertical. Right. And
can you say that one more time?
So the lapse rate is the vertical temperature gradient. When the lapse rate is 1 degree Celsius per 10 meters, then the radius of the ray of light is 6,300 kilometers.
So that would match the measured empirical lapse rate of 1 degree per 10 meters happens to be what is required to bend light along the contour of the Earth?
Yep, the same radius of the, yeah. And it's
Okay.
and it's rarely exactly that, right? If it's more than that, then light will bend down more and hit the surface more and reflect off of the surface if it's a shiny surface like water tends to be. Okay,
Yeah,
just a second. I had one more thing before again, on my website, mc2.net/refraction, I have several of these. I have a list on there, and the final one that's on there is the one that is particularly to the point where they use the lapse rate and they measure the curve and how much and match them up to determine empirically how much they match. So the point is, 1 degree Celsius is enough to curve light if it's over 10 meters. So if it's less than 10 meters and you get a 1 degree change, it's a big deal. It's gonna curve the light more.
That would be a lot of refraction.
Yes. So here is my personal measurements using a NIST certified thermometer on a lake in Minnesota. So here we have at, this is just above, what's this, 18 inches. So it's half a meter, right? I did these, I have an imperial tape measure, but I did it at metric elevations. So half a meter.
Go metric.
Yes.
We really should. Ryan's way ahead of us in Canada.
Do science in metric. So 0.2 degrees Celsius at
base 10
at half a meter. Here is at 1 meter, 0.7 degrees Celsius. Here is 0.9 at 1.5 meters and 1.2 at 2 meters. So we actually get a full degree change in 1.5 meters, which is a significantly higher lapse rate than is necessary to bend that ray of light more than the radius of the Earth. So I don't know if that hits you. I don't know if that sinks in, but this means that over ice, the index of refraction, the coefficient of refraction. Coefficient of refraction is how much light bends in relation to the radius of the Earth. The coefficient of refraction is very high.
Okay, so I have 2 questions here. One might be, would the lapse rate be as strongly increasing here on ice? Would it be similar if you were doing it over warm water? Because we've made long observations over warm conditions. And then I would ask too about the lapse rate or the implications on the refraction of like, again, for the linear observations we make in the natural world and then the attempted recreation of a curved piece of material. Is the lapse rate using glass mediums and salt water, sugar water, are those comparable to conditions we could find in looking over water in our natural world?
Well, those are like the one from Jesse. That's a proof of concept that he didn't do anything to measure the index of refraction gradient. And of course, the lapse rate that's in the air is significantly different than the salinity lapse rate in a tank of water. I don't know if anybody's done any of the application of the salinity lapse rate in a tank of water. I think that's probably outside what anybody would have previously been doing it. But the point
that's a frontier of science.
It certainly somebody could do that. But I think that the point is it was a proof of concept. Can and you asked the question, so this was just to answer that, can an index of refraction gradient cause something that is definitely curved to appear straight? And as we saw, then yes.
And I think that is important to note too, that these are like, maybe you would agree, Mike, that it's important to be able to have kind of maybe these rough outlines of proof of concept where you can kind of show it, and then to be able to, if you have the engineering, the apparatuses, the level of precision, you can get more into controlled experiments and isolate more variables and set things, and then you can use those laboratory empirical extrapolations, and you can turn them into things that you're then able to predict with. But I think it's good to have these proof of concepts to show that things are tenable and plausible, and that they can actually then hopefully be tried to be used to establish a further understanding of our world.
Just to inject right quick, Nathan, because I know that you're just about to go on this next thought. Before we get too far back down into what we were discussing, we got lots of questions in the live chat, and that is going to keep you guys potentially tied up for a little bit. But I want to check, how much longer do you guys want to keep the open discussion going before we get some of the audience interaction, push the conversation along? Because I don't mind if we have a long Q&A where you guys are, expounding on what people are talking about, because it seems you have a lot of ideas. But what are you guys thinking? Maybe 10, 15, or did you want to get there quicker?
I have one question or one topic that I'd like to bring up, and maybe Nathan has one.
All right, let's give it 10, and then we'll get to the Q&A there, guys.
Okay.
And we can try. We might be swift here. We'll see.
Okay.
All right. Well, we'll see. Don't worry, fellas. Don't let me rush you.
In your presentation, you said that the seasons on flat Earth are caused by the sun moving in and out. And I have got the good old Gleason projection from the globe map. So the sun doing small circles in June and doing big circles in December, and varying between them. So the radius of that rotation is varying constantly in a sine pattern. So what is the cause of the variation in the radius of that circle?
So the philosophical framework for a flat Earth, as far as like the medium that carries light, would be the ether, and so there would be a rotating vortex that interacts with light. It also appears to have some impact on matter based on the Elias effect, an eclipse with a pendulum swinging. So if you think of like a bike wheel, you have the center, and then radially out, the whole bike wheel turns at the same rate of, we'll just say 15 degrees per hour, or 15 degrees per unit of time. And so you would have, no matter where you're at, so long as you're on the spoke, that same spoke, you're going to keep your 15-degree heading. There would just be an increase as you go outwards. You would have a greater arc to cover. And so that would, from what I've seen and heard and gathered so far, it appears that sun rises and sun sets in the northern summer are they take kind of a while. There's light lasting for a little bit, for quite a while longer than in the northern winter. Southern summer, the sunsets and sunrises have a much briefer twilight time, as opposed to what would maybe be a symmetry because of the Earth. And Mike, do you know, is the globe claimed to orbit the sun on a plane, or is the orbit as well tilted, not just the Earth's axis of rotation?
Well, yeah, the Earth orbits in a plane.
Okay,
and
so then the
plane is not identical to the other planets in the solar system.
Okay, so then what I would suspect then would be the case with the globe is, if you have a globe tilted, and this is
I wasn't asking about the globe though.
No. I'm just I think it has to do with the vortex of the ether rotates, and so everything on that spoke, if you're closer in or further out from the center, you're going to keep that rotational heading because the whole apparatus is arcing in the same angular distance. It's covering the same whether you're in or out. And I do believe with the sunrise and sunset, that I could get on.
All right, let me re-ask the question, because you didn't really go to answering it. You said that the sun moves in and out through the seasons, and that's what causes the seasons. So what causes the sun to change the radius of its circles above flat Earth?
So I do believe the sun was made with a path set in mind. It could be an interaction as far as like the phenomena of what's pushing and pulling the sun in and out. It could have to do with the positions of the.
That's good. I don't need a whole bunch of what ifs, right?
Okay.
If you don't have an actual empirically verified answer, then just say that, and then then the audience can say, okay, well, it's just faith, right?
Yeah, and that, well, it would be, I think it could have something to do with the charge, how far away it is.
Just guesses. It's just it could
it is, but
this,
again,
it could be this.
it's
None of
the
this is
sky,
empirically
and
verified.
that is something that I do admit that the sky is a frontier to us, unlike the earth. Yeah, but it is something that I think is I have hypotheses and speculation, and I think using a bike tire as an analogy, the sun is staying within the vortex, and if you put an object in a fluid and you rotate the fluid, it's gonna keep that heading. Yeah, I would probably go with something like that. Could I sorry, that might not be a sufficient answer, but I mean, I will initially off the bat, I'll claim that the sky is a lot less substantiated, from my understanding. Do you mind if I ask a question?
Well, if I could strap it.
Go for it. Respond, yeah.
You in the beginning of your presentation, you talked about falsification, and so you don't even have a falsifiable guess as to what it could be. So that's not science, that's not scientific, that's not empirical. It really is just a faith. So,
would you equate the ether to, this is not my question, but playing off of that, would you equate the ether, which is maybe not as substantiated as something like dropping a pen, would you substantiate that with space-time fabric? Because that also is not able to be quantified, is able to be manipulated or malleable or handled or measured. It is also mathematically conceptual. It's a framework.
Yeah, so the bending and warping and the properties of space-time have been empirically confirmed. The properties of the hypothesized ether, which at one time both of them were just hypotheses, but the hypothesized ether being specifically the luminiferous ether, or what Klinkerfuse called the undulating theory of light, being the medium through which light travels. That particular definition of ether does not have any empirical evidence for it. But I do agree that versions of ether can and have been falsified by empirical testing, but I do believe that there are ether frameworks that are able to account for. Well, yeah, and so then when you change the definition of it and assign the name ether to it, it gets confusing because now the word is overloaded. You've got multiple things that both have the same name. So
well, if we approach it scientifically, we could discard those ether theories, like Feynman said. If it doesn't conform to the evidence, you throw it out. So we can throw out that ether and then form a new ether framework, and then try to explain based on our updated observational gatherings, our updated understanding of how phenomena are, the variables, the conditions that can cause things to be.
Yeah. So all of that needs to be done, though. Right, there are just kind of some ideas. There are some vague ideas and some less vague ideas. But
yeah, well, I'll
confirm
back to, if it's like if it came to where I had to really make a stand, I would still claim that what goes on up in the sky, if the whole sky turned purple, that doesn't mean that the grass is purple. What goes on in the sky is secondary to the primary of the ground of geomorphology, the shape of the topography. So that said, actually, because one of the other things, and we've been talking a little bit about the sky and the shape of the earth and everything, and so observations along water. But one of the other distinguishing mutually exclusive claims of a globe versus a flat earth or still earth is the motion itself. And so I'm curious, because the globe does claim that the only absolute motion. I could have a couple questions off this, but I wanted to just run something by you to see what you think about it. The globe claims that the rotation is absolute, and then you have the orbit of the sun, the galactic orbit, and then the orbit or the drift of the galaxy as it exploded from the Big Bang. Those are all relative motions because of the space-time fabric. So I am curious. The Earth moving would supply a force. And actually, if I could share my screen real quick here. This here
Yep, you're up and running
is
now.
awesome. So this here, I don't know. Oh, I can zoom in. Whoops. Hold on one sec. So
I can zoom in
this,
for you if you'd like.
uh, this here is a diagram that shows it's the gravitational force, centrifugal force, and the effective weight. So even so, and I haven't done it myself, but people have said that they've measured is if you go to the pole, an object weighs more because you have these double compounding, the full effective weight is going all the way down to match gravity. If you go to the equator, you get a counter, the centrifugal force and the effective weight are kind of going at it with each other. So it makes an appearance of a lighter object at the equator. And if you'll notice, all these red lines are actually, they're all going straight to the center of the Earth. Gravity goes straight down. So what you get here in this 45-degree area is the greatest amount of centrifugal force. And so this actually would equate to something that is like a tugging, that it would pull us towards the equator. And what I was told is it would be about the weight of like a tomato of pressure. Like if you set a tomato on your arm, you would feel it. And then if you move it to another part of your arm or wherever, you would feel it if it was resting there. So if you are looking south at the equator, the back of you is the one furthest away from the equator and is what is feeling that pulling. And say you look south deadlocked the whole of your life, it would be constant, so you would never notice a change. But if you turn in any direction, you do not feel any sort of change of where that tomato would be on your arm. You don't feel a change in the further away from the equator side of your body. You don't feel that change being applied to that new area. And so I'm curious what, like, when we drop an object, no matter if we're at the equator, at the pole, somewhere in the middle, doesn't an object go straight down without any sort of tugging influence to, maybe it's just not dropped high enough, but my understanding is things go down.
Okay, so yeah, a good question. You took it off the screen. I was gonna say.
I'll put it back up. I'm sorry.
Put it up. So what you do is you sum the vectors. Vectors sum.
Back up.
So.
Just wait. We're still waiting to see your screen there.
At that middle one, which would be about 45 degrees north latitude where we live, you can see you've got the downward vector of gravity. You've got the sideways direction of centrifugal force. It's not straight up when you're not at the equator. At the equator, it's straight up. Everywhere else, it's slightly modified. But you sum those vectors, and that's what that is. That the blue, I think. I'm colorblind.
Yeah, purple.
Yes, blue, purple. Okay, so that's the sum. That's all we feel is the sum of those. So all right, you can take that off the screen for a second.
So okay, hold on. So you said we feel the sum. So this here, the sum is off tangent from straight down where gravity is.
Yeah.
So we do measure things falling off from straight down.
Yeah, all that we get is the total, the summed forces together. So, all right, if whoever played the game Descent, it's a first-person shooter in space. You're in a spaceship. It's pretty old. It's way too old for me to have ever played, being just 13. But rumor has it that people have played it. In that game, and other first-person shooters of the era, some of them had a quirk where if you move straight forward, you move at speed, say, 1. And if you move sideways, you move at speed 1. But if you move forward and sideways at the same time, you move diagonal at the speed what?
1 squared plus 1 squared equals c squared. Uh,
Two,
well,
square root of 2.
2?
Square root of 2. 1.4.
Okay.
So you actually go faster if you do both at the same time because it sums them. Now, future games fixed that problem, but people that were really good at it would use that to go faster than you could normally go.
For speed runs.
Or if you're doing first person, PvP
Better to move
type
quicker.
stuff. But you're looking sideways when you're doing that. So you have to get good at it. You need to know the map, things like that. But people they exploited that. So that's what happens when you sum vectors. So we got that. So we have that vector slightly off.
So there's a skew.
Yes. So, but the quantity is very small. So at 45 degrees north, you take
Let's go for another 5, guys.
Cosine.
Let's go for another 5. You guys are doing good. This is great.
Cosine of the latitude, I think, is how much you get from that. But because of where we are and the angles there. So I'll show you. And you're exactly on. You're right here. And so I have this gravity challenge that I did, and the point of the gravity challenge is to predict the downward acceleration, not gravity, the downward acceleration better than gravity. So it's $10,000. I have money in escrow. I have it all written out here. I can't change the rules. There's even a checksum there. So if I vary the rules, you'll know. So, but the point is that there's a method. I described the method for the globe, and it's not the ideal method for the globe. But I'll show you the method that I use. I use the law of gravitational attraction. I use the second law of motion, and I use centrifugal force there. Or sorry, this is not centrifugal force. This is essentially the gravitational field strength, and then this is centrifugal force. So in my challenge, I did not sum the vectors the right way. I did that on purpose. It makes it easier for flat Earth. Actually, it's actually easier math too. We don't
Why
do
does it
anything
make it easier for flat Earth?
Because because it's not as precise as it can be. But in order to be as precise as possible for the globe, then the math is more complicated. And I thought, I'm going to keep this as much as possible to freshman high school level math.
And things that favor. So are you just, you're someone who would say, hey, if I'm going to offer a challenge to the opposition, you want to try to favor the opposition as much as possible, give them as much slack to try to, rise up to the challenge.
Walk away for 1 second. You guys are all, what's going on here?
Okay.
we good.
Okay.
So, all right. So I'll run through this really quick. So yes, the downward acceleration is higher at the equator, at the poles, and lower at the equator. So here's let's see what I use. Yeah, Fortaleza, Brazil is the one I used here. It's close to the equator.
Are you asking for a downward measurement? You're asking for measuring the rate
measurements have been done, and I have documentation of where the measurements are.
And those measurements are straight down?
The direction is unspecified. It's just the magnitude.
So is there any way can we measure or detect the tomato pressure tug towards the equator on an object? There
are ways to measure the deflection of the downward acceleration at different latitudes. It's very precise, and it requires looking outside the Earth.
Whoa!
You have to use an external. You have to use an external reference.
That seems difficult.
It is
because we're talking about the Earth, so you would have to do that from space.
No, you'd have to do it from Earth looking to something in space, like a distant star.
So looking at the star is used to determine gravity?
No. You were asking
the sideways
specifically,
force of gravity?
You were asking specifically how could you determine the offset of the downward vector on the surface of the Earth relative to the true tangent at that location. And that's what I'm talking about. So that requires, this is outside of any of the stuff that's in this challenge, but that requires looking at an external reference, which we can't just sit on the Earth and not have just look internally. We don't know. You have to look externally to do that. So
are you dropping to get those kinds of precise measurements? You're dropping an object and seeing it fall down, and then you're comparing it to how it drops, like with respect to a stellar object?
no. Great.
Hmm.
The amount of deviation that you're talking
Last word
about
there, McToon, before we
what's that?
go.
All right. It's very
I said
small.
last word for you before we go into the Q&A.
Okay.
Go ahead.
All right. Well, the measured downward acceleration in Fortaleza, Brazil is 9.7. That's the sum of all the vectors. And in International Falls, Minnesota, 9.8. Slightly higher because we're at a higher latitude. There you go.
All right. We'll end the
Do we
screen
get,
share.
Ryan, do we get closing?
Oh, you'll definitely get a closing. Don't worry there, Nathan. We'll definitely give you a closing. Or sorry, if you prefer to go by Pitch Lumen.
You can.
I'll
It's either's fine. It's, as long
You've
as
been
you're nice.
tripping
I don't
me
know.
up, buddy.
Sometimes people are mean to me and I still respond. So
Oh, it's all good. Well, I appreciate you being here. I appreciate both of you. Our speakers
it's
have
been a
been
pleasure.
awesome this
Really,
evening.
both of you.
Honestly, this has been great to listen to. When I have speakers on that are as great as you guys, it just gives me a chance to just interact with the live chat and fix things like McToon is now back in
I'm
our
back.
live
Thank
chat.
you.
He's
Yeah.
back, right? To make an Aerosmith reference. All right. So if you haven't
Get
already,
at him, y'all. Mike's there. Go talk to him. Ask him questions.
these fellas didn't believe me that I do rock music. Yeah, they don't believe that I like screaming at people for money. It's like free therapy. All right, so we're gonna go into Q&A, everybody. If you haven't already, like I say, hit the like button, share this out in the spaces that you like having these types of discussions, which I know all of you like hanging out in those Facebook groups. I see you. Don't worry. I'm hanging out in there too because I gotta find all our lovely speakers. So let's get into the Q&A. Tango 44 for $20 says, question for the flats. All of New Zealand is in daylight 3 hours before Sydney. Sydney is 2,225 kilometers from Wellington. NZ is 1,600 kilometers long. So why does sunlight take 3 extra hours to travel 625 kilometers? New Zealand? Sorry, I just said.
No problem. So it could have something to do with if the light is going through a certain part of contour of the firmament, it would cause kind of a muffing of the ability of the light to travel, so it could slow it down for those portions. And then by the time that the light actually reaches Sydney, it would have gone past that part of slowing that the curvature of the firmament imparted on the lights. This again would be something set up by an all-wise creator who has all the distances and everything, and that's what we observe, and then we measure, and then we build our model off of that. Yeah.
All right. Any thoughts on the other side there before we move on to the next question?
Yeah. What ifs aren't science. It's what is asserted without evidence is dismissed without evidence.
And I would to say to that, I would say the sky is not the primary when it comes to the ground shape. So.
All right, we'll move on from the old Hitchens slap, everybody. But if you haven't slapped the like button, give it a go. It will not displease you, I promise. PT Collins says, Nathan, assuming the Earth is stationary and the sun is moving above us, shouldn't we expect a more dramatic change in the sun's angular size?
That's it. So yeah, with perspective, when an object, especially along the ground, when it moves away from us, it goes through the speed changes of parallax. It'll start to appear to move slower. It'll appear to shrink. That is true. The object that we're looking at on the ground is close to us. It's out to 3 miles to the horizon. With perspective, when you look up, there's more visual data in one section of field of view. It covers a greater span. and that carries true all the way through the sky as it goes down to your horizon. So when you look up at things that are elevated, there is the apparent size and the apparent shape actually are less. It takes much more for them to change. So the elevation actually helps keep the shape of the sun and the size of the sun, as well as things like water vapor being like magnification to help enlarge the sun as it goes away, and things like that to help it keep its appearance. There are variables in place to help it appear, which
5
if
seconds.
we're considering an intelligent designer, that would be an intelligent design to make a sun that no matter where it's at can be the same size and the same apparent view to help with the light properties and everything of the sun.
Thanks for wrapping that up. And just before you get into too much there, did you have any other thoughts on the other side? And I do see in the live chat, it's MC Tune. Sorry about that earlier.
Yeah.
I'm married to a Mick, so you know, said it naturally.
I'll just go with Hitchens Razor again.
Okay.
I'll go back with
Let's-
Earth over Sky for determining Earth.
All right, let's carry on there, fellas. This is fun. And honestly, like I said, one of the most amicable discussions I think we've had on this in a long time. So big kudos to you guys. You know, you made my life a breeze tonight. So especially after all I told you guys already, it's fine. Kango 44, Nathan, it's very easy to measure the shape of the Earth. Bob, the science guy, did it with total stations. You could do it in an afternoon. Ooh, Kango's coming for you. What do you think?
Okay. Yeah.
Bob,
So
the
okay.
science guy did it. Apparently.
Say we're gonna measure the size of
Not sure
the
he
Earth.
does.
Let's even throw it out to like Eratosthenes or these ancient Grecians who knew 2,500 years ago that the Earth was a sphere. If you're looking out to the horizon and you see a boat disappear bottom up, is the horizon at 3 miles away approximately or exactly? Is it 2.9 or 3.1 depending on refraction? Were they accounting for refraction? And then they take the 3 miles is 6 feet hidden. And so we can extrapolate that into a globe with the given circumference of 24,901 miles, or whatever unit of measurement they were using back then. How are you getting, are you assuming your radius? Are you assuming the distance to the horizon as opposed to having a firm fix? How are you making a measurement without having some sort of refraction put into
Feel free to inject, Mike.
The measurement?
Nathan, let's go this summer and make it happen. Let's measure it ourselves. How about that?
Yeah, I'm game.
Road trip.
Let's sit and
hear
experiment.
No, we live near each other. We can do it.
We do.
Yeah, we'll
Yeah.
go to a lake, set up elevations on either side. and do
Come
it.
on, guys. Come to Nova
We got to get a
Scotia.
big body
I
of
don't
water.
wanna
We should go to,
travel.
I don't know how long across is Mille Lacs?
Mille Lacs is not calm. That's the problem. We need something that's got it
Tranquil
helps if
waters.
it's got trees
near
around it.
near
Like
surface.
Cedar Lake north of Calhoun is a good one. Maybe, I don't know.
Would that be long enough?
It's long enough. Yeah.
Bidet Makaska? Yeah. Oh, okay. So somewhere in the Isles.
Ska.
Yeah. It's just,
I do apologize, Nathan. I'm sorry if I cut you off. Yeah, it's just that
No.
I have reviewed the questions. A lot of them are going to be, directed towards your arguments that you made tonight. So
That's fine.
if I inject just to try to get Mike in there, it's just, like I say, for the sake of engagement and trying to make sure that we have some things that can be addressed so that it's not like, too much gets put out there before we can get into it, right? So
The more questions, the better, as far as I'm concerned. Whatever gets to truth, because if I might just interject here real quick, regardless of the shape of the Earth, whichever it is, I mean, there are people out there who, I know it's hard to believe for some, but there are people who are willing to harm others for their own gain. And so if the Earth is a globe, all religions are false. We can stop religious wars and everything because they all claimed at one point a stationary centered Earth that would falsify all of them, the Bible included. Whereas if the Earth is planar, we expose lies of people who are trying to manipulate us, control us, and so either way works, and whatever gets us to the absolute truth can bring unity and can get people to at least agree on peace and not harming one another. Then we at least can prevent the preventable things. So I'm fine with whatever questions that help us get to really where the potatoes of the argument or whatever, whatever. So I'm fine. All questions, please. I encourage them. That's why I have a channel. I ask stuff, and I want to know too. I used to think the Earth is a globe. I loved astronomy, and now I want to know. I'd like to live on the same Earth as my loved ones. So, yeah.
Well, yeah. I was gonna say, I think I think that one was pretty directed. I don't know if you have any thoughts there, Mike, but I honestly feel like I might have a question once we wrap up, just because you sparked me there. So, any thoughts
Hey,
there, Mike?
you can hop in the Q&A too. Go for it. Ask God. You're here. You got.
No, it's fine. It's fine. We'll save it. The audience can just sit there and smolder and wonder.
No
what
one's
was
gonna
it
know
Ryan
Ryan's
asked?
question. Whew, all right. Fair enough. No, let's get. Yeah, I'm. Anything's fine. Really, I encourage open dialogue, free speech. I'm huge on all that. So, and I think that's really like I love science. I love questions. I love questions. I love critical analysis, critical thinking, strengths and weaknesses of arguments. I think all that stuff is amazing. It allows us to innovate with science. So.
Well, not to inject again, but we have LJ here actually. So let's ask LJ's question, because it's going to be for you, Mike. Has gravity ever been measured as force? When?
As force, directly as force. You measure it. One way to measure it is with torsion bar, and that it's an indirect measurement, like most measurements.
Because gravity is not technically a force, right?
That's a reference frame question. Within our reference frame, it exhibits itself as a force.
Is the torsion bar appealing to Newtonian mechanics of matter attraction?
It's just mass attracting mass. So there's no distinction between that, because Einstein's field equations solve to Newton's law of gravitational attraction for the specific things that we have in our reference frame, which is low velocity and low mass.
Okay. So Einstein has to incorporate an explanation for low velocity, low mass objects.
Yeah. Einstein includes.
They're built off of Newton, was the claim.
Yeah, the Einstein's field equations include application of velocity and mass, where Newton does not. So Newton is a simplification of Einstein. I mean, it didn't happen in that order, but you
wait, doesn't Einstein, isn't that force equals mass times acceleration? Isn't that velocity and
that's
mass?
not Einstein. No, Einstein field equations.
No, isn't that Newton?
Newton is Newton's law of gravitational attraction is force equals mass 1 times mass 2 times a constant, a gravitational constant, all of that over the radius squared. There's the distance between the centers of mass squared. The F equals ma is the second law of motion, which is also attributed to Newton. So he gets a lot of credit for different things, but it's just the second law of motion.
All right. Seems like we're all in agreement there. We're all just kind of jiving along. If you're jiving along and you're enjoying the discussion, let's bring it up here. Like we're an old MC announcement. We got MC tunes, so let's do it.
Ladies and gentlemen,
hit that like button. Yes, let's get ready to Q&A. Next one coming in. Kango says, Nathan, please explain in detail a sunset. Ding. I figured that's what he meant.
Yeah, so that would be the I think I kind of showed it in my slides. You have the sun moving away from you with perspective. You have different compounding variables in the air that would alter the size of the sun to keep it constant, the shape of the sun to keep it constant. And as it moves down, it's going to appear to set behind the vanishing point. And once you are beyond, every elevation has a set vanishing point given the conditions. And so once you go behind that vanishing point, it's not going to be able to be seen. And then if you increase, you're going to push further back. This is why you can go to from the bottom of the
Oh, your mic got covered up, Nathan. Your mic got covered somehow.
My mic is it's my laptop. Can you hear me?
Yeah, I can hear you. For some odd reason, all of a sudden, it sounded like you put a cloth over your microphone. So can you
Oh,
repeat what
sorry
you
about
just
that.
said?
Yeah, okay. So you have a vanishing point, a hard vanishing line that, given your elevation, you are going to have a certain amount of distance of ground you can see and of sky, and so anything that passes that is going to be cut off as it goes. And as the sun, for example, would go down, bottom up, it would enter into that line. And so that's why, for example, like in Dubai, there's a building where you can see the sunset at the base, and then if you go to the top, you can see the sunset again, because as you increase in elevation, that hard set vanishing line at the back of the perspective of what you're looking at is going to be pushed further out, so you can get more information compressed into that bottom half and the top half. And then and then you have the sun and sky, they're colliding, and then that they're competing for visual. You can only resolve so much with your eyes, so they get into competition with very, very small things off in the distance, and they cancel out and create that vanishing point. And so the sun goes behind that, and it sets or rises, depending on which way it's coming from or going from.
And all right. Any thoughts over there, Mike, or you want to carry on?
None of that is how things work. Those are just assertions and incorrect claims about how light works.
Last thoughts for you. 10 seconds there, Nathan.
Incorrect thoughts about how light works. Let's see. So I do think if you go up in elevation, you can see more ground, you can see more sky, and so there is something being pushed back to allow you to see further with both. So I think that those would be observed.
All right. Well, thank you so much. Let's carry on there, fellas. Yeah, you're right, Max. I should always moderate with the wrestling voice, but I don't. I used to do the impressions and all that, but I've since behaved myself. So
Your ticket
yeah,
pays for the whole thing, but you'll only need the edge of your seat.
that's right. That's right. All right. So free Palestine. If somebody asks for Jordan Peterson, I'll do it. I swear, I'm in that mood. Why? All right, so free Palestine says why there's no polar stars at the south and only polar stars at the north. Answer: Earth is seriously flat and stars are not light years ago. Stars are underwater. Check out Star in a Jar experience. Sonoluminance. I feel like I should have read that with a Jordan Peterson voice because the cadences in this was difficult. Go ahead. I think
All
that
right,
one's for
there
you,
is
Vinny.
there is no star at the true center of rotation in the north or the south. Polaris is about half degree away from the center of rotation. So the premise of the question is false to begin with. Then the rest is just claims without evidence. The distances to stars have been empirically measured. Not the time to go over those now, but they've been measured. And if you want, you could probably come on my channel. We'll talk about it. But I think that's Earth is seriously flat. Is that you, Renee? Sonoluminescence is definitely not how stars work. The Fraunhofer lines of stars confirm that there's a particular thing that's happening in physics to cause the light to be emitted.
Any thoughts there, Nathan, or you want to carry on?
Yeah, if I could real quick share my screen here.
Oh yeah, we're gonna Sunny and share. Let's go for it.
Ooh,
Right,
I
that
see
was
what
too
you
far.
did there.
Too far.
I'm a dad. I get away with that. Go ahead, Nathan.
No, dad humor, dad jokes is the most elegant form of comedy, even over puns. It's the most elegant and refined source of comedy, in my opinion. So this here, to the claim of stars being different distances away, like what I had showed here is you can see how objects in the foreground actually move a lot quicker and cover a larger span of your field of view than more distant objects. So this here shows the hat in foreground. It moves very quick along the screen compared to the light back here it doesn't cover the full gambit of the screen. So more distant objects because we have observational parallax, a lot of times cosmology parallax gets put out to like the Earth on both sides of the sun, but the falsifying parallax to different claims of distance is the observational parallax. All objects in the sky, when we look at a time lapse, they move at 15 degrees per hour, regardless of where they are, how far away they are or close, because some stars are claimed to be very close, some are very distant, but they all appear to move the same, which would be like if you were looking at a bunch of bat bags here and they were all in the same line. They would all be moving at the same distance, whereas we're not seeing something like a close star like a Proxima Centauri versus a very distant star or light in the sky moving at a different rate. They're all moving uniform, which would imply equidistance as opposed to variation of distance. Like I've yet to see any parallax, anyone show any parallax that can refute close objects versus far objects, and having fast moving close objects, slow moving far objects. It happens all the time with our optics and with observations.
All right. Any other thoughts there?
Yeah, in
Tune? You had some
1839,
going on.
Friedrich Bessel measured the parallax of star 61 Cygni to be 0.314 arc seconds. The 6,000 about closest stars have been have had their parallax measured with a couple exceptions. So it's been measured. If you want, I can send you citations. I've got on my website. If you just go there and search for stellar parallax, you'll find a long list of
please, if you could send me those. I do ask though, is it parallax, like looking at the star from one side of the sun or the other, or is talking about nighttime shit? Because this would be the parallax I was showing there with the screen share and with the revolution of the Earth over one night. That would be a nightly parallax that we would see every time.
If the stars were close enough, but they're not.
But they are different. It's not a matter of it's not like after 2 light years away, suddenly everything is far enough to appear uniform. There's a scale. So distant stars.
It's not 2 light years. It's the width of the orbit of the Earth.
So many Q&As there, guys. So many Q&As. Let's try to move on from there.
I think that's a big one.
I think one way or another, no matter what we're talking about right now, we're gonna make it full circle before we get out of this Q&A.
Oh, like the stars. Oh,
oh, you stop that. You're trying to tap me. All right, let's see here. LJ. Oh yeah, a bunch of people did say they wanted Peterson. Oh my God. Okay, let me see if I can conjure this up. If the moon was physical and asteroids were real, we would have countless non-CGI videos from Earth of asteroids hitting the moon by now. Why don't we? Oh, that was bad at the end. I went too Kermit on it. So yeah, if the moon was physical and asteroids were real, we would have countless non-CGI videos from Earth's asteroids hitting the moon by now. Why don't we? That's for you, Mike.
Oh, we do.
Yeah, and I actually, to Mike's answer, I don't know if you're done there, Mike, but I would like to say there was a video that I saw, I think it was from about a year ago, maybe a year and a half. It was an amateur astronomer, I believe in Japan. It's called like a moon impact crater or a lunar impact. And someone actually caught a bit of like a light flare on the moon that was claimed to be an asteroid hitting the moon and puffing up dust high enough above the moon's surface to get illuminated by the sun, and then it settled down. But there are claims like that, but I think it might be plasma or something like that. But personally, for what I think the moon is, those kinds of things
plasma. But all right,
I haven't been there yet. If we were going to go off of,
thank you for supporting my answer.
Well, yeah, I want to throw out what I've observed, but I will say, like, if we're going off of what is empirically. Have we ever measured moon rocks or tested what they're made of? If we're going off of the empirical measurements, the claim of moon rock is driftwood, so we're testing
It's
trees.
It's not driftwood. Don't straw man. You didn't look it up.
There was a case of driftwood.
You didn't look it up. Don't make that
Wasn't
claim.
it given to the Dutch or the Prime Minister of Holland?
You did not. All right. I'll explain it.
Send it to me. Please send it.
No. You brought it up. I think I deserve to explain what really happened. Yeah. So the claim was that the Apollo 11 astronauts gave a moon rock to one of the ambassadors for the Netherlands. The Apollo astronauts never gave any moon rocks out to anybody ever. The moon rocks were given out through diplomatic channels. And it wasn't in 1969. I think the first moon rocks to be given out were later than that. So the claim is that some Dutch ambassador has a moon rock, but it wasn't actually a moon rock. It was petrified wood, not driftwood. But there is actually no evidence to suggest that anybody thought it was a moon rock, because the actual label that was in the display case. So these things were found in a drawer, and then a display case was made from them. There's a little paper placard of some sort that says, given to him, the ambassador, by the Apollo astronauts, but it doesn't say what it is. And then the moon rock was placed next to it. Not the moon rock, the petrified wood, which was in the guy's drawer as well. So some people made the connection that the petrified wood was what was given to them. That was never the claim. It was
a
never
misplacement of the material.
It was a misunderstanding of what happened. There's a couple people that have done a full write-up. I have links on my website to them. If you search for probably the Netherlands on my website, you'll find it.
Okay.
Or petrified
Check out
wood.
MC Tune's website.
All right, let's carry on to the next question. I put up a silly little poll there, so if you want to vote on that, that's fun. Let's carry on there. Ooh, my mouse is doing some strange things. All right, so let's see here. LJ, having a degree only proves you can memorize books. That's a bit more of a statement.
Not always.
I don't know if that warrants too much here because we have so much, LJ, to respond to, but you had your huzzah. You catty. All right, let's carry on. I love you.
Hey, actually, real quick, if I might add this to that, because with I was on a debate recently with somebody. There are many people who have degrees, who work very hard, who report on honest data, who are very intelligent, very wise, very nice people, and they do good work. There are a lot of degrees. Going to school for medical or for trade or anything like that, those are helpful to society. So I've had some issues with the school system myself, but there are definitely positives to being educated, having a literate public so that we can read and discern things for ourselves and communicate with each other. I think it's very important. So anyway, thanks for the soapbox.
No problem. You know what? I did up that poll, but I have to say, honestly, you guys have set a new bar for engagement. We've got lots of Q&A, and I think it's because you guys have made yourself so palatable for our live audience that they can't help it. They want to engage.
Science is amazing. The discussion.
Let's see. Kango44 says, Nathan, sunrise in Sydney, Australia is 3 hours after New Zealand is total daylight. New Zealand is 1,600 kilometers in length. Sydney is around 2,225 kilometers from Wellington, New Zealand. Why does the sunlight take an extra 3 hours to travel 625 kilometers?
Didn't you ask that already?
I think we read that one. It's the travel of the light. The dome might slow the light down as it travels the distance. So but the sky, not the ground. So again, I mean, the sky's purple, so the ground is. I play baseball. It's a round ball, a round bat, you round the bases, hit for a rounded average. Therefore, the field must be round. I think there's a misconnection there.
Dude, no problem.
This is going to be 12 hours if we do this.
Yeah, sorry, okay.
Can't go
answer the same question
again. I gotta.
Yeah. We've only got so much time here, everybody. So, and our speakers already, they were like, "Let's go for a long one, guys," because we're having fun. LJ, how were solar eclipses predicted pre-globe model? That's for you, Mike.
For me, they were before the globe. The path of totality was not predicted before the globe. All that they had before the globe was identified patterns in the day that they were likely to happen, sorrow cycles, and they did not know the location. They did not know the time. They didn't know how much of it, whether it was annular or total. None of that was done, so they weren't doing much predicting they weren't doing any predicting based on geometry. It's simply based on repeating patterns. But now, the specific location of the eclipse is known years in advance. The one in April coming up The path of totality is known. It's known how much of the sun will be covered. It's a total eclipse. The amount of time that the sun will be eclipsed is known. All of these things are well known. It all uses the globe. It does not have any flat Earth geometry in its calculations.
And I would say to that, maybe if we're talking ancient times, there's no telephones or anything. It's harder to get information to travel distances. So maybe if you're observing an eclipse in India compared to England, people in India might have eclipse data from their viewpoint of the sky there, whereas England would have theirs. And so you might have a problem relaying information to be able to put together whole
But it's
works
about
of
predictions.
eclipses.
They didn't do
Well, yeah.
predictions.
So now we have the eclipses. Now we have the data. We have databases put together, and it's cycles. So you have cycles either going around the Earth or above the Earth, but they're still cyclical. And if you have enough data points on the cycles, you can have the full cycle map.
This particular path is not based on a cycle. This particular path has never happened before, and it'll never happen again.
But you could see where, if eclipses happen at such a frequency, you can see where the moon will travel.
No,
and whereby you can plot that.
You don't know what
Last
time.
10 seconds to McToon.
Yeah, you don't know what time. You don't know the location. You don't know the totality. All that requires geometry.
All right, let's carry on. Free Free Palestine says the analemma is evidence of a local sun and Polaris. For you, McToon.
And Polaris.
Sorry, MC Tune.
So the analemma is hey, I have never seen any flat earther compute the consequences and then see that the output is analemma. How high is the sun? You don't know. How far away is the distance across flat earth? No flat earther knows. All of these things are necessary in order to relate the flat earth model, the geometry of flat earth, to the analemma. The analemma is a very specific claim about geometry. Now, the analemma is evidence for the earth being a globe and that the orbit of the earth around the sun is slightly elliptical. That's what the analemma is evidence for. And somehow Polaris, I don't know why Polaris was in there, but Polaris is not in the dead center. It's about half degree off, and it measures to change in location annually.
Before you respond, Nathan, I want to check with Mike. I'm cool to keep this going as long as you guys want it to go. You guys are super cool.
We've got to end it. We can't just go indefinitely, though.
Okay, cool. I was gonna say I know how long you're willing to go now, Mike. Let's just leave it out of context. Don't put any context on that, and we'll just carry on with our live chat. I told you I was a dad. I make some inappropriate jokes here and there. It's fine. Jesse Bergs says, a while ago, Toby Cotton of the Dude Perfect group went up to out of space. And on the video, we can see that 1, he floats freely. 2, we can see clearly from the window of the capsule a rounded Earth.
Yeah, this one's for me to answer, right?
I think so.
Yeah, buddy. See, I was going to try to put this into my slide, but I couldn't really fit it on there. I was going to throw it in with flights, with the airplanes and everything. But if I pull this up here, and then I guess, exit that and then go to here. And then if I share my screen and I click on this, is this, okay, now it's just about to pop up.
Screen shares. All right, let me just make our faces a little smaller so that we can see your diagram. Oh my, our faces
is this on this? This is on the screen.
Yeah, I'm just trying to make our faces a little smaller
Bunch of
so everybody can see it.
Curved rectangles or something. So this here actually is a diagram of a plane window, but these and I don't know if it has to do with making them more having more structural integrity, having a stronger a more toughness, but window panes on flight craft are curved. They're actually physically curved, which can cause the effect of seeing what appears to be curvature. But if you look at the Red Bull jump, which I actually think I have here, you can see that you also have you can see that you get the planar. You have a flat horizon. You have weather balloons
There
that
we
can
go.
go 120,000 feet in the air, and they reveal a planar flat horizon.
Can you
a
send me
science
one?
popularizer.
Nathan, one with a non-fisheye lens. Can you send me one at 120,000 feet with a non-fisheye lens, non-GoPro? Just one.
Well, yeah, I'll send you what I got. But I will say
don't
too.
don't
So
go up there because I've seen them. I've seen them all. All the ones that show a flat are GoPro lenses, and they're cherry picked just a couple seconds or a minute or 30 seconds, whatever, where it's at the correct angle to make it sort of look a little flat. Typically, the edges are curved up, making it look concave. But find one with a rectilinear lens where we know the properties of the lens.
okay, yeah, I will.
I dare you.
I'll find what I got because I will say like the dog cam video that goes up. You can it'll as the camera wobbles and oscillates and everything, you will get the horizon to appear.
Yeah.
Not
the right one to use. Yeah, that's a GoPro.
But they don't convex and concave and then appear flat at the middle.
Sure they do.
You can see level at different tilts and angles.
Yeah.
No matter which way it's oriented.
Yeah. So I don't know why you'd want to use a fisheye lens. Use a rectilinear lens instead.
But a fisheye lens curves the further away you go from the center of the lens.
And it curves opposite directions, above the center frame and below the center frame.
But that dog cam shows no curve, whether the horizon appears lower than center or above the center. It appears plain. It appears straight, especially not the curve level of a fisheye.
It does not. It's not a fisheye. Fisheye is what a lot of flat earthers say for GoPro. GoPro are not
a barrel distorting lens.
Barrel distortion, yeah. Yep. Find one that's not a GoPro. Find one that doesn't have strong barrel distortion.
I hope I came in at a good time, guys. You sound like you're right at the end of the
Yeah,
thought.
we're done.
And
You're good.
it's all good. I just had to check on my son. He was calling for some water, so Dad to the rescue. Let's carry on.
Get it.
Yeah, I was gonna
That's
say
always got to make time. That's
well,
Dad's
yeah,
gotta do.
not 9 and a 6-year-old, right? You know, it's one of those things that every once in a while you hear in the background, you're like, aren't you supposed to be sleeping? I'm in Nova Scotia, everybody. It's 12 o'clock right now. If
Midnight
those
there.
kids aren't asleep, I don't know what I'm supposed to do.
Those
They're
2-hour
just
lists are
wild.
so nice though.
Let's carry on, guys. Oh my goodness, there are so many super chats. We might have to set a timer. If Mike, you have an intention of getting out of here in good time, let's set a 2-minute timer for these questions.
That's a good idea.
Because we'll be here all night if we don't do something else. All right. So Jassy Berg says a while ago, Kobe Cotton of the Dude Perfect group. Oh yeah, we already went. Jassy Bergs says again, lengths of train tracks in southern places are much shorter than what it would have been to be on a flat Earth. Why ignore the clear evidence for a globe?
So yeah, I think the distances over land, I think we can measure pretty well because they're over land. We know if we're laying a 10-meter section of track, it's going to be 10 meters. As far as the contour of the land, if it slopes at all, if you're trying to go around the turn or anything, it could change the straight line distance to distance, actual distance. Like if you go straight over something versus having to take a hill, it's going to appear longer if you take the hill. But I do think we can know distances over land pretty accurately as far as the spacing between them over like southern oceans and everything. I mean, even a few years ago, there were problems with flights disappearing and stuff. So maybe the continents have their shape, but also too, the military does own the GPS and they don't give away a lot, like their most accurate data for reasons, defensive purposes, to not have direct pinpoint location of any craft or anything, but they withhold the most accurate maps. And the UN, the International Civil Aviation Organization, the USGS and all these, they all use a flat Earth logo for whatever reason as their logo. They don't use like one of those bendy globe things that looks like a letter M or anything. So I think we can accurately know. And then I showed in my slide in the bottom corner of one of the slides, I showed a map of the United States. It's like one of those things you would fold out in your car. It's a flat map on a flat piece of paper. It has a key, has a scale. You can travel with it. It shows rivers, it shows roads, it shows highways, it shows cities, all that stuff.
Time there, Nathan.
Maps.
So
Okay.
we'll give Mike a chance to respond to
the
some
very
of what you
specific
said.
question was about distances over surfaces, which you said was primary, not secondary, tertiary, primary. And so the distances of things like train tracks are well known across Australia. You talked about it with PhD Tony. Match the predicted distance when you compute the consequences of the globe. Matches when you compute the consequences of flat Earth. They don't match. That's science. Flat Earth falsified. Unless you have a different way to compute distances between points on flat Earth but no flat earther has ever presented that.
That is done.
We've done the polar distance formula for you, but you don't like it.
So I would say to that
That's what I am saying. Last word to you, Nathan.
we can make a map of maybe a local area like Australia and have a map, and we might not have it laid out as far as resolution and everything to try to put it to an entirety flat
5
Earth map.
seconds.
But there are no accurate globe maps or anything either.
Yeah,
so
there are. Yeah, there's definitely accurate globe maps.
Well, you'll get a chance to expound
coastline
on
paradox.
that in just 1 second. You just wait before
Okay,
you
yeah.
trigger.
No, we can wrap that. No.
You're good.
Fine.
All right. Leo Crow says, over to you, MC Tune. I got to get used to saying that too, just so I behave myself. What evidence do you have for the sun actually operates by nuclear fusion? This has never been proven in human history and is impossible if indeed maintains an axial rotation. 2 minutes on the clock.
Non sequitur for why it would be impossible, but has it been substantiated? That's a good question. Not super familiar with the details of it. One of the things that is done is spectroscopy to know the particular makeup of it, and knowing the distance and the angular size, we know the linear diameter of it. That gives us the ability to determine the mass of it and what happens in the center of it. So these things are, of course, yes, we nobody went there, nobody scooped out a bucket of it to test what it was. You have to, just like basically every single measurement in science, every single thing in science, except for the very most elementary things, you have to do something other than just looking at it and grabbing it to see what it's made of or what it does or how big it is or any of things like that. But Melodic Lyrics is a good point. Fusion gives off some neutrinos, and we do measure them. So there you go.
And I do think like the globe would have to explain what a star is and try. Nuclear fusion is a part of the cosmic evolution of the universe, with stars fusing light elements into heavier elements up to iron, and then they go supernova or red giant, and then they explode and become higher elements. So that would be the claim. It's the phenomena claim of what stars are to help allow for the idea and conception of a globe to be able to be non-conflictory as far as how we get these higher elements and everything from a big bang producing helium, hydrogen, and lithium. But yeah, it's the model. But yeah, I would question.
Right, back to my very first part of my presentation, the flat Earth has nothing. You need to compute the consequences for your claim and then see what the sun is. If you're claiming that the sun is local and small, then it's on you to provide the evidence for that. So asking me for evidence when you don't have it, hypocrisy.
I think a sunspot, a local sunspot. Okay.
Oh, okay. Yeah. I was going to say, actually, you know what? It's good that you wrapped it up there because that was for Tune. Mr. E-Man, can the flat earther explain the change in the length of day throughout the year?
Yeah. So the sun on flat earth model, the claim would be that the sun is making a small circle in the northern hemisphere, and then inner circle on a flat earth model. And then as you go further away, the sun moves away from you, and it does increase its speed to keep its 15-degree-per-hour heading. And so you're getting a more distant sun. You're getting faster traveling sun. You're getting less direct sunlight because it's further away. It's lower in the sky typically, so you have more atmosphere, more thick atmosphere to cut through with the light. And so these things would all cause, the variance in days as the sun ebbs and flows, small and large and back into small circles again and again as it makes its solar cycles.
All right. Was that
a lot of circles. That's good. I mean, yeah, I think if Mike's cool, I mean, if he wants to answer that or anything, it's cool. But that seemed kind of like how would a flat Earth explain this, which I'm sure Mike might know about how the attempt of explaining the day length is and everything. But again, too, like if you look at the crude example of that dome and everything, it shows a similar light
Oh,
pattern to
see, Mike is
accommodate.
back.
I have a response to that.
I was just about ready to ask him my question just to push it along, but you know what? Save it for after
my
this.
response
Go
is
ahead,
quick.
Mike.
Hitchens razor. Over to you, Ryan.
No, let's carry on. Let's carry on. I thought you might be gone a little bit longer there, Mike, but you know,
That's all I have.
You're that's all I have.
I know what his answer is. I didn't
you're
need to be
talking
here to
about-
hear it.
You're talking about your response, not the bathroom break, right? That's all you have.
Yes.
All right, let's carry on. All right, let's carry on. Let me scroll up. And I say scroll up because there's a lot of questions. I'm setting 2-minute timers, but you guys are just, going about 30 seconds over. So PhD Tony says, PhD Tony, yeah, you were talking to him last time. Can Toon name a material? Oh, maybe this isn't the same PhD Tony. Can Toon name a material capable of supporting its own weight over spans of thousands of kilometers? If no such material exists, how can a firmament exist?
Yeah, there is no known material, and I suppose if you were to compute the consequences of a firmament, a dome of some sort, that would have to be 12,000 kilometers, or sorry, 40,000 kilometers in diameter, and an unknown height. But it doesn't matter. Some tall height. The material behind that would be quite something, including that the claim is that there's water on the other side of it. So how would that happen? Boy, that's a high bar. That which is asserted without evidence is dismissed without evidence.
Yeah, and I would say so. Like, I think the hardest object that we have is diamond. I know like hydroxyapatite on our teeth is pretty hard as well, but like we have these hard substances, and so but we're able to break them if we want to, or if we do the right things, apply energy to them or anything like that. But if the creator, who's all powerful, all capable, makes an unbreakable material because man cannot go into the heavens, then no one is going to get past that or be able to scratch it or test it or anything like that, extract material to then be able to analyze, because God made it unbreakable. It's the firmament, it's the sky, it's the barrier.
Thoughts there.
Hitchens razor.
Okay. Toby Walker coming in. Why do globers pretend that we perceive space in Euclidean and ignore the fact that train tracks cover in distance? Toby Walker says, to follow up on my previous question about train tracks, do parallel lines ever actually converge in reality?
That's a great question. So parallel lines. So on flat Earth, you've got the flat Earth, which would be parallel to the plane that the sun is in, and so they do not converge in reality. So the sun could never set because they never do converge in reality. Thank you for that, Toby. But we do not see in Euclidean or in hyperbolic space. I did read that paper, but it is just human perception about distances of things that was hyperbolic. It wasn't actually that humans see in hyperbolic space. And of course, measurements devices like theodolites, which is what was used in that particular paper, don't have an issue with that. They measure angles, they measure specific things. Not a problem for them.
And to that, I would say if I draw this here, this circle, if you have the Earth and you have the sun setting, why it does actually appear to set is because if this here is the vanishing point and the sun is going this way, once it crosses this vanishing point, it's going to appear to set behind something, because just because the span of the Earth is great doesn't mean that an observer's vanishing point is the same or comports to that, because if you go up in elevation, you change your vanishing point. You can bring a set sun back in.
The point of Toby Walker's claim, though, is that parallel lines do not converge. Therefore, there's no actual thing in reality of a vanishing point where part of something would be obstructed due to the vanishing point.
All right, let's move on. I'm not picking on you there, Nathan. These last two were for McToon.
No,
So
yeah, that's Mike's last word. Yeah.
yeah, no worries. Let's carry on. LaBelle says, why would the knowledge of the Earth is flat be kept from the global population? What would this accomplish? Detailed answer, please, and thanks.
Yeah, you got it. That's a fantastic question because it does get into the why of a lie and everything. So one, it's I believe to hide the Bible. The Bible claims the specific use of the number 666 as the mark of the beast. 666 is in the amount of curvature per mile, 0.666 feet of curve per every 1 mile. We orbit the sun 66,600 miles an hour. There are things with NASA having devil horns. Jack Parsons, who studied under Lester Crowley, who called himself the wickedest man in the world, 666, Baphomet. So there's a lot of
Jack
ties.
Parsons died more than a decade before NASA.
He was part of JPL, Jet Propulsion
He
Laboratory.
was fired from there
and still
for his
part of
occult
it.
beliefs.
And you do have Werner von Braun, who has on his tombstone 1911 Psalms, the firmament declares the glory of God, or the heavens declare the glory of God, the firmament shows his handiwork. It is to hide God. It is to make people feel not special. It particularly helps for the military, where you can dehumanize your opposition. The people serving in the military mean well, a lot of them, but on the other side too mean well. But they're human beings. But if you can get them to be like an animal, or you're painting a target, you're subhuman. It can try to be easier for people to harm others, but people still have trauma from it because it's traumatic to hurt others to a human being. So it's to hide God. It's to discredit the Bible, because if the Earth was a globe, the Bible would be falsified, and so that would it's all. And I mean, controlling everything too, but the Fed and all that can print money. So
Oh, I said last 10. I'll give you a last 15 and we'll carry
on. So yeah, it's all, you're very special. You're very loved. And it's to hide the creator, to hide special creation.
Why are there so many 666s in flat Earth? There's 66.6 degrees from the North Pole to the Tropic of Cancer on flat Earth. And on flat Earth, the sun moves 1,666 miles per hour as it circles the North Pole. Coincidence? I think not. Why does Witsit Gets It in base 34 have 666 in it, and in base 35? Why does Flat Earth Witsit have 666 in it in base 35? Huh? Why does Brian's Logic Flat Earther have 666 in it? It doesn't matter. It's just.
I think if you're appealing to like the 36 decimal place or something, you could.
Yeah, it's the same. It's the same as you did. Same as you did.
Just 666
hunting for
666 readily available.
I can hunt for 666s just like you can hunt for 666s.
I mean, they're in barcodes and stuff, and the Washington Monument measuring everything.
Nothing to do with the globe.
All right, before just 1 second there, Nathan. We got all kinds of questions. I don't mean to cut you off.
We can. That's a good question though.
There's like 20 more questions, and you guys are just gonna trigger me to like sing Iron Maiden if you keep saying 666, because it's one of my favorite albums. I'm sorry, like no matter what you think of me, The Number of the Beast is a great album.
It's referenced a lot. Why, if the Bible's false, why is
it's Nero's
so
number? It's Nero's number. It's not
because Bruce Dickinson is such a great singer. Anyways, we won't get into that. Shane St. Pierre is saying, all right, Tequila is better. I like Rob Halford more. But let's carry on. Do train tracks appear to converge in the distance? Do parallel lines ever? This is the same.
I think we got
that. It's a great question from Shane. Thank you, Shane, for asking that. No, parallel lines do not. And he brought it up. I mean, yeah, the sun could never set. Great point, Shane. Thank you for that.
Yeah, and Shane went on to say, can you then conclude that Euclidean geometry perfectly describes visual space?
So we do see an angular, we see 360-degree field of view, and as to the sunset not being able to set on a flat surface, I showed screenshots of oh, my bad. Sorry, I'm jumping here. I'm twitchy.
I get my time. We do see in Euclidean space, but humans' perception of distance is not good. All right, go ahead, Nathan. To the topic though, don't stray.
Okay, yeah. So we see in angular, and we do have devices that are capable of like linear measurements, and then we just look at the graduation marks on a linear degree device or something like that and try to get our measurement. So I mean, we see in circular view, but we can do things to determine linear measurements and things like that. So
Thanks, Shane.
All right. All right, everybody's triggering my Dioisms. Okay, all right, there you go, Issa. Yeah, we do Stargazer, Kill the King, Terror Woman, a whole bunch of them. I love Dio. I can't get enough of that. That's my jam. 80s metal is just so good. But it's a natural thing. When you get into guitar, you're gonna eventually love. Yes, I see. Look, Metallica over there.
hey, can
Go
I
ahead.
real quick? There was a former coworker of mine. She wanted to go to a concert, but her like past boyfriend was going to be there, so she felt uncomfortable. So I told her I'd go. It was to a metal concert. I don't listen to metal music or anything, but when I was there, I was jumping around and everything. She had a good time too, which is a great thing. But I remember I was sitting there trying to fake drum, and I was drumming slower than the actual drummer who was drumming to rhythm was actually drumming. And he also had a shirt on that said like "will work for sandwiches" or something like that. But he was real drumming faster than I could fake drum. And it's some of the like the instruments, it's very high octane music and everything. It's like wow.
Yeah, I was gonna say, yeah. If what am I thinking of here?
Maybe a different show
Literally,
is about music.
It's just, yeah,
I
different,
love metal,
but
but it's
that
just different show.
powerful music.
oh yeah, no, I've enjoyed lots of Judas Priest, and I've seen them live.
Come on,
They're-
Ryan.
Rob
Focus.
Halford's
Focus, Ryan.
fantastic.
Focus.
Back to it. I'm sorry
Focus,
for jumping
Ryan.
off the rails there.
Let me have
It's good.
fun.
I gotta moderate the
MC2.
moderator. Come on.
No. We can discuss how much we love metal for 2 seconds. My goodness.
I'm not a fan. Some of it's good though. Some
Yeah, all right. Witsit gets it. All right. Is this what you wanted, MC? Is this what you wanted, really? Witsit gets it is here. And he says, to the Glober, would a required correction for anesiotropic signal propagation for GPS refute relativity, thus heliocentrism? You asked for this, MC Tim.
Probably not.
I was trying to spare you.
Probably not. And I like how Witsit is too scared to type my name.
All right. Let's carry on. Shane St. Pierre. If Arun Wang generalized the Sagnac effect in 2004, then why did the Michelson-Morley interferometer fail to measure Earth's orbital velocity?
The Sagnac effect and what Michelson-Morley were measuring are distinctly different types of measurements. Michelson-Morley was a linear measurement, and the Sagnac effect, which is what Michelson-Gale and Ruyan Wang is, has an enclosed. It's in a circle, and the light paths go opposite directions. So they're different instruments measuring different things. Sagnac effect measures rotation, and the hope of Michelson-Morley was that it would have an effect on it because of the Earth moving through the ether, but that they didn't find that. So
yeah, with the Michelson-Morley, they tried sending light at different times of the year, different directions of the Earth relative to what they thought was the orbit of the Earth, and they got a fringe shift of I think about 1/6 of what they were expecting, roughly around there, to the 30 kilometers per second. That light is a very sensitive measurement device, very precise with those fine wavelengths and everything, and they would have been able to calculate or to get a difference based on the travel. Once you release the light from the source, the objects keep moving, and light is the only constant in relativity. It's the absolute frame that things are based off of, but it did not measure the supposed orbit of the sun, thus
No.
relativity saying it's all in.
yeah, it did not measure the effects of ether on the light. That's what that's what the experiment was doing. It was measuring the effects of the movement of the Earth around the sun in the hypothesized ether. The movement of the Earth around the sun was not the hypothesis. It had been previously confirmed. The very first sentence of their paper references one of the earlier confirmations of the movement of the Earth around the sun.
All right, let's carry on,
I think it was
everybody.
from Isaiah.
And
That's good.
yes,
That's something to that though. Yeah, how they
ooh,
portray
I love
it.
metal.
Aries failure,
Yes.
Aries success.
ask me about all your metal questions in the live chat. That's lovely. Let's carry on. It's fun. Let's see. Ruang. This is the same. So similar question, similar vein. Ruyong Wang measured linear motion using interferometry in 2004. Why didn't Michelson Morley detect the motion through Einstein's linear geodesic? Oh, I can't say these words.
Geodesic.
Thank you, fellas. You are fantastic. Go for it.
So again, they're different experiments, but Ruyan Wang had a loop. There's a loop in the instrument that he had where light gets split and it goes opposite directions, and inside the loop there is an area. It's not a zero area. So, but Ruyan was testing if moving the actual fibers had an effect on it, and he did get confirmation of that, and it's completely in line with relativity. I Can Science That, I think, did a great analysis of it, applied all of the math to it. It's really good. Go ahead and have a look. Maybe somebody can
If
get
you
the
do check out
specific
I
one.
Can Science That, he did talk about the Ruyong Wang experiment because Space Audits was covering it. And actually, I Can Science That did make a video that I saw. It was the last one of that series of covering that, where he did say that actually what Space Audits, Alan and them were finding was that it actually would be able to falsify the constant speed of light claim and show a favored direction for light. He actually did agree with what Space Audits and what they were claiming and reporting on. I believe I Can Science That. If I'm wrong, you can correct me, but I believe that's what I had heard from it.
All right. Seems like we've wrapped up all of our thoughts there. Medicinal Mass Media says, Demonstride says, nuh-uh.
Demon Stride.
Demon Stride. Well, thank you.
I think.
Get out of here, demons. Get out of here.
Sorry about that. I don't think
Get
we
behind Jesus, demons.
Get behind Jesus.
I don't want to
Yeah.
think there are bad people out there or anything. I want to think people, care for each other. And I don't think I met anyone, heinous towards others.
I was just parroting
You're
you,
probably-
so like don't
Yeah,
get
okay,
upset with me.
Just an
It's
it's
fine.
there's a lot of reference
Yeah.
to demons and stuff in today's world.
Yeah, no, it's fine. Witsit gets it yeah, we already read that one. Sorry, Witsit. Medicinal Mass Media says maybe with a bunch of dots. Not sure what you meant with that. Shane St. Pierre says to the globalist, globularist. That is a weird way of spelling that. To the
Globular
globi-
list.
The globularist.
I don't
Oh,
know.
what a strange word. Do you think compressing an image literally depicts actual Earth curvature?
Do you think what actually exhibits?
Do you think compressing an image?
Yeah. So if you have a photograph of something that's got very slight curve, then sometimes people will do a horizontal compression of it so you can see it. Of course, you can measure it, you can count pixels, you can draw straight lines across it if you want. But to make it a nice visual aid, people will sometimes compress it horizontally to really squish it. And then if you do that, what happens is straight lines remain straight and curved lines are easier to see as curved. So yeah, it's a great way to identify curvature.
So if you're taking an image of something that you're going to compress and you're using a lens that has barrel distortion and imparts curvature onto what you're
It's
taking,
a
and then you
separate
compress it,
topic. You need
Okay.
to control for your lens distortion as well.
Correct. Okay.
All right. Let us carry on into the next question. Toby Walker says, why did Maurice Alice find the pendulum precessions periodically match that of the sun and the moon rather than the rotation of the earth?
That one's for me. He
Troy's
did.
buddy.
Yeah, he did not. That was an experiment that was not confirmed. So a very important part of science is that it's repeatable, observable, repeatable, demonstratable, those things. So in the higher quality repetitions of it, they did not find the same effect as Elias did in his earlier ones. And it did not, whatever he was implying in there wasn't actually what they found. They found a very slight, he claimed to have found a very slight variation in the precession of the pendulum during the eclipse, and a very slight change in the period of the pendulum also.
I don't know if it was slight from what I had seen, and I actually think NASA or Harvard had also tried to has had some successful and unsuccessful results of an Elias effect during eclipse, even underground. But I think at Elias, what he had reported was that during an eclipse, like an average pendulum, if it's right set right and everything, it'll go 15 degrees per hour. But I think he had reported that it was up to like 13 degrees faster per 15 minutes, or like 52 degrees an hour swing, which is actually quite large of a rapid change. And I think it can even go backwards and stuff during an eclipse, which would show it's not independently the rotation of the Earth, which is a constant during an eclipse. It should remain constant during an eclipse. It actually shows that there is a sky influence on matter.
If it had been confirmed, but it wasn't.
Well, I think NASA has seen it sometimes and not other times, and same with Harvard as well.
Yeah, that's the problem.
From documents I tried looking from the other.
All right, let's carry on and ask more of these super chats. And if you have any other questions in the super chats, you can keep them coming in. But we do have to wrap this up at some point, I'm sure. I'm gonna set those 2-minute timers, but you guys are just you're rocking it, so I can't help it but just let you guys expound. Toby Walker says, and a follow-up, why does Apollo 17 lift off from the moon like a high school video project? Isa, I just shared the folder with you. Enjoy the medal. Go ahead, Mike.
I don't think it does. When you look at high quality video of it, it looks fine.
I think it looks like,
yeah. If you think it's fake, then go ahead and show the forensic analysis of it.
I'm just really happy that they were able to send men to the moon in one shot, first time, and get everybody landing there safely. It wasn't the first time. And their return back.
What number was it? It was 11. They orbited the moon in 8.
Didn't they have to touch down at some point?
They went partially down at 10. It wasn't the first shot. It was the 11th.
But the first time they landed on the moon and then had the LEM get them off of the surface. So
the first time they landed on the moon, they landed on the moon the first time? Yeah, that was the first time. The 11th, it was the 11th time that they had done in that particular series. They had Gemini and Mercury missions before that. So it wasn't the first time. They didn't say, here's our first rocket to launch, go to the moon. That wasn't it. They had a whole bunch of prior ones for many years.
I'm just happy they made the 249,000 mile journey there and back, made it safely. That's good. I want, safe travels, everybody.
Last word for MC. If you have any thoughts.
Got nothing. Yeah.
Okay, cool. All right. That makes it even easier. Winter Gets It is coming in again, just to ruffle your feathers. Remember when you admitted to Jaren that compressed images actually are not valid evidence of Earth's curvature, but you present them anyway.
I don't remember saying that at all. I think that compressed images are a great way, as long as you've controlled for other things, to determine whether or not something is curved. It's good for seeing it, but better to measure it, and you can count pixels to do that. I have a pixel counting thing I did with Tommy Grunwald's picture against a straight edge against the horizon.
And these pixels you're counting, this is discernible curvature to tell the difference between what would be our field of view curvature and an actual physical horizon.
It's a photograph. It's a photograph of a known straight edge. So we are controlling for the lens. It's a high quality lens, not a GoPro. So we have the actual physical known straight edge in the foreground, right next to the horizon in the background. And then I counted the pixels between the edge of the straight edge and the edge of the horizon. Yeah, so I had controls for confounding variables.
And the horizon is 180 degrees across. It's not at a slant or anything. It's 180 straight.
It wasn't 180 degrees. It's not that kind of lens. It was a narrower field of view than 180.
All right.
Okay.
Let's carry on, fellas. LJ, why hasn't space tech improved since 1970?
It has. That was quick.
They
I
got to
think-
the moon then and can't now. I
Yeah,
think they're working
definitely
on
is.
small, achievable goal steps to take to get us back into space exploration to the moon and then to places beyond once we get to those steps. And I think Dear Moon and these companies that have been saying in 2023 we're going to go, it's the 2024 now. They're going to say in 2024 we can go, and then it'll be 2025, 2030. Virgin Galactic was doing
It
it.
has nothing to do with the question, though, Nathan. The question was, why has tech not improved? And it has. So,
But there's claims of space travel and everything, and we can't do it currently, which
But
would
it
be
has
a
improved.
regression from going in the past.
but it has improved. That's the answer. The answer is it has improved. He claimed in his question, he implied that it has not improved, but it has. So it was an incorrect question.
I do agree if rockets are considered space technology, even though it happens within the Earth, if you can land the booster of a rocket straight up, that's all happening on the Earth, but that would be improved booster technology for what it's worth. So, yeah.
All right. Kango 44 coming in. Pitch Lumen. Your video showing a bottom-up obstruction. Is that what boats going over the horizon looks like to you? Question mark. Or sunsets. I'm not sure what your cadence was supposed to be there. In your video showing bottom-up obstruction, is that what boats going over the horizon looks like to you? Or sunsets? There, I think I got all of the emphasis on the right syllables.
Yeah. Yeah, so that would be like how that experiment or that demonstration shows bottom up disappearance of those objects. That is a bottom up disappearance that you could also apply if it's a horizon. It's like the sun. We see it set or rise, bottom up, top down for rise. But we see that, so it would be the same conditions that would affect the bottom up disappearance of a boat, of a building, of a sun. It's the optical effects of our atmosphere plane that cause us to see bottom up disappearance, which is striking considering typical thoughts of a flat Earth, and especially if you don't include atmospheric conditions or anything. You would not, if we didn't have an atmosphere. I do not think that the sun would appear to set. We might even see it all the way across, but I think there's attenuation of light and everything due to the magnification, the dispersing of light, and things like that. The medium changes, bending light down, so it can't reach you if it's far away because it has to bend down. It's bend down and it falls short before it actually reaches your eye. Sorry,
Any
Batman.
other thoughts?
That's not how
Or
bending
here.
downward light works. It makes things appear higher.
Last word to you, Nathan.
Ben, yeah, the light would, yeah, it wouldn't reach the observer because it's being cut off by the atmospheric conditions before it can reach your eye. Because we have an atmosphere, we can't see the sun at all times. I do believe if we didn't have an atmosphere, we could, and then you could do the geometry and everything, and calculate the height of the sun and everything if there was no atmosphere and medium change.
All right. So I think what we should do, fellas, because we got so many super chats, is we should move into a speed round, and do this almost game show style. So I'm going to set a 45-second timer, and we're going to try to keep these questions for the speaker. I know there's a certain propensity you want to respond. Let's try to save that for your closer if you've got any extra thoughts. So, I don't know how to say this name. Churk Avenger says, does light bend towards or away from a denser medium? Which way does the light have to refract to make an object appear lower? 45 seconds on the clock.
Light would have to bend, refract up to appear lower, and in a denser medium, it bends down. I think I've got that right in terms of refraction.
Well, this
Denser
is
medium down, so.
it seems like you're both kind of engaging here, so go ahead. You
That,
got 25
that's fine.
seconds.
I think that yeah, I think I answered it, so that's good.
Do you have thoughts, Mike?
No.
20 seconds? No, okay. All right, let me reset the old clock there. We suggest people read through the Transcontinental triangulation, and the American arc of the parallel, where they correct planar measurements and globular long systems and heavily correct the celestial sphere. 45 seconds. Over
That
to
was
you.
all lies. Thank you.
Any other thoughts for your 47?
No, he just lied a whole bunch.
All right. Did you?
I've read it. I've done the math. I've got all of the details in a spreadsheet, all of the numbers. He lied.
Ooh.
Who
Ooh,
was
he
it?
lied.
Was that Shane?
Shane's,
Yeah.
That's Shane
Shane
St. Pierre.
Shane, you should read it, dude.
Ooh,
You
he's
point
coming
out
right
the
at ya.
specific place where they do those things, where they put those numbers in, as you say. What page?
Spicy. Mike's not holding back at this point
I
in the
love
debate,
Shane.
everybody.
He's great. I like him.
Well, that's good. I was going to
We're
say,
all
sometimes when you
friends.
have those relationships with people you disagree with, you can be a little extra spicy and just be like, you know what? All right, let's carry on. White says, why all planets are round except Earth? 45 seconds,
Yeah,
Nathan.
they appear, round or circular or anything like that. Just again, I mean, if they appeared like squares, that wouldn't make the Earth a square. If they were a certain color, we see stars twinkle different colors, but our sun doesn't twinkle, so they're not all doing the same thing. You can't apply one object to every other object. It's considered when you consider an alternate cosmology, you have to consider their claims, not try to graph um, solar heliocentric claims into the geocentric claims. Again, if I play baseball, round bat, round ball, you make square contact, rounded batting average, round the bases. There's a round mound. Is the field itself um, round? The poles are straight. Is the field still round or is it straight now? The lines are straight. So it's yeah.
All right. Pseudonym coming in. Did Globe agree there's an 8-inch drop?
There's an 8-inch linear drop from horizontal tangent. Yeah, 8 inches per mile squared, linear drop from horizontal tangent. But it's not useful for predicting the bottom-up obstruction without further calculations.
All right. Toby Walker. Why do GPS or range measurements equations rely on the relativity velocity of the receiver? Second part. Einstein was wrong about the speed of light and Earth's rotation. Well, just putting that big one in there at the end,
Yeah,
Toby.
yeah.
Thanks.
Yeah, amazing claims for you, Toby. Amazing claims. I look forward to your papers and the Nobel Prize you will get.
Any thoughts about what he said about the GPS range measurements equations rely on relative velocity? No? Okay. Well, let's carry on. We're more than halfway through. Don't worry, fellas. And like I said, 45 seconds. We're going to just try to speed round. How
got this.
come nobody has ever reported or seen the edge of a flat Earth? Do you think somebody would have observed that at some point in history? Also, satellites prove the Earth is round. 45 seconds, Nathan.
If there was an edge with waterfalls going over it and everything, I'm sure someone would have found it. I mean, then again, if they found it and fell off, hopefully they didn't, but we wouldn't know. Or who knows where they went. The Antarctic coastline's a big wall and everything, and so you can see pictures of it, and it goes around us. It's like a cup. If you don't fill it quite up all the way, you have the walls of the cup. That's essentially Antarctica. And satellites, they have military technology, satelloons, various things that they can put up. You can look up quantum levitation, quantum locking, so they could potentially be doing things with cold metal craft with receivers in them that could cause some sort of
Come on, Nathan.
floating and levitation. It's the military. I don't know. They have incredible
Nathan.
technology.
Just conjecture. Come on. Just
I mean, there are
things you can
balloons
actually
up there.
back.
There are long distance, long time flight
All right.
objects that they have, like solar panel powered planes.
Our
and
timer
everything.
is up, and
Military is
also,
well advanced. So
if you saw me shaking my head, I'm sorry to cut you off. If you saw me shaking my head, it was because
yep,
I
you're
choked
good. You're good.
I choked on
We
my
can
own
go to the next.
spit. Yeah, that's fine.
Wrong
It
pipe.
happens every once in a while where you just kind of like breathe in, and yeah, never mind me. Toby Walker says, why do GPS's range measurements equate?
You already read it.
Yeah, this is the same question. I'm so sorry, Toby, but I don't think we're going to get much more on that. I'm so sorry. Pseudonym says, does he know a radius doesn't rely on curvature?
Does he? Me?
Oh, that might have been for me when I was asking about like Eratosthenes and the Greeks and everything. And then, so if you're trying to, my understanding would be if you're trying to determine the curve, the circumference of the Earth, you can look out at a boat and you can say, okay, if we can see at 3 miles that 6 feet is hidden, we can work that back along the contour of an arc of a circle of a sphere, and we can determine at 2 miles there's X amount of curve, and at 1 mile there's 8 inches of curve, and at 10 miles there's 66.6 inches of curve. And then you could scale and say, okay, now we can make a ball. We can take this little portion and we can extrapolate that out and wrap it and get a full circumference. And that's using the horizon, the distance of the horizon, the curvature rate that we would perceive. And again, that's were they factoring observer heights? Were they factoring refraction and lapse rate and all these things back then to where they were able to get an approximation within what 5% of what the Earth is now, or 2% or 2.5% or something like that? Did they have all these variables accounted
Nathan,
for?
that's not how they measured the radius of the Earth.
So then we'll go to Eratosthenes or the Styx, Cyrene, and the well.
Yeah, I did.
All
Yeah,
right,
it
let's
wasn't.
carry on,
It wasn't
fellas.
what you described.
Okay, I might conflate them a little bit, but yeah, the horizon now is changing. You can't determine the horizon, so you can't.
Yeah, that'd
you
be a
can't
terrible
take
way
that bit
to
and map
measure the radius of the Earth. Use something else where refraction isn't so wild.
Well, let us move on. Witsit is coming in with another super chat. A lot of people are making fun of me because I choked. That's fine. You know, it happens to the best of us. Yeah, I'm in Canada, you know, it's really dry here every day. It's dry. So, like, don't blame me. Witsit gets it says,
Ask NASA to make it rain.
can you steel man? He wants to know, Witsit. He wants to know, can you steel man sunsets on a flat Earth?
Certainly, I did in my
Mike.
presentation. Yeah, I measured the distance to the subsolar point. I measured the elevation of the sun, hypothesizing flat Earth, and according to flat Earth, sunsets are not possible. But Austin, you say you have no model, so I can't steel man your not model. It doesn't exist. So I had to make the model for you, buddy. You know, a little bit of geometry. I know your math isn't your thing, but I did. You know, it's about ninth grade math.
All right, let's carry on there. Toby Walker says, how do relativists explain a Fresnel's drag?
I don't know. Ask a relativist.
Are you a relativist?
Yeah, but
By
it's not
any
my
chance?
it's not my thing. It's about the shape of the Earth. Nobody can explain a sunset. What time will the sun set tomorrow in Minneapolis? No flat earther can explain that, and you want to ask questions about relativity? You're way out of your league, guys.
Okay, I wasn't sure what he might have meant.
I don't know
if
what
you,
I don't know what that topic is. I'm unfamiliar with that topic. So
And when I said you, I was passing the buck. So I mean,
yeah,
you
yeah.
know, Nathan, if you consider yourself a relativist, then you may have been able to answer that. But if you
Certain
don't, then
things are relative to other things. Sure, I mean that's kind of a
That's not what he's
half
talking about.
coverall, but I mean,
okay,
you know,
Mr.
relate
Ian.
things.
Before we get off track, guys, because we've been really on track for a long time, and then we steered all over the place. Mr. E-Man, can Nathan produce any evidence to support the hypothesis of the evidence of the aether?
So the ether would be a philosophical framework that we can then try to reason with, extrapolate logic from, and try to make predictions of characteristics of light. If we create a disturbance in the ether or increase the excitation level using light emitters, light is gonna, I say it's gonna travel from its source outward. It's gonna radiate out, and so it's a framework
10
to
seconds.
allow us to address light. It's literally it's the same thing as space-time fabric, which is 96% of your model, or dark energy, dark matter, and all that. Those also are philosophies, but they're claimed to have physical properties, whereas the ether is Well, the ether can
That's tough.
influence matter a little bit and have light carry and everything, but it's a philosophy, and it's not. I can't quantify it for you. I can't grab you ether and hand it to you just like, hey, I'm going to grab you space-time fabric and knit you a shirt with it or something.
All right, let's carry on.
Yeah. Okay, go ahead.
No, it's okay. If you guys want to carry on, it's up to you. I'm trying to push this along because
Space-time has been empirically
Push it.
confirmed, and
Go ahead.
luminiferous ether has been empirically falsified. There you
I
go.
believe models of ether have been, but there are ether models that can still work.
But not the one that you need.
All right.
Well, there's other. If some are falsified and some are there, the ones that are there are still able to be used.
Let's move into the next one here, guys. And I'm going to move our timer down to 25 seconds just because, like I said, we were asked to keep this to 3 hours and we just got to 3 hours. So we're going to try to really push it along to help out our speakers here and get them out on a reasonable time because we really, we really appreciate the speakers that come out here to Modern Day Debate. If you haven't already, hit the like button. And once again, if you're hanging out in those contentious spaces, or if you are a contentious space, share it out. It never hurts. What do you got to lose? Mr. E-Man asks, that's me. We just asked your question. Witsit gets it. Oh boy, Witsit. Every time I see one of your questions, I'm like, oh god, what's Witsit up to now? Honestly though, I love you, buddy, and I can't wait to host you again. It's been a pleasure hosting you every time and meeting you.
You spent
is
two minutes waffling.
Is it? I will waffle.
We're over.
Is it possible
Stop
to
waffle.
have a uniform, vertical electrical field with parallel equipotential surfaces like the Earth around a sphere without radical distribution?
Radial distribution. So Witsit is making a claim based on Feynman's lectures. I'm sharing it right now. He likes to quote Feynman's lectures starting at 9.2, right here. 9.1, Feynman's lectures. By about 50 kilometers, the field is very small. It is not equipotential. Witsit, read your own citations. First law of Lerf.
All right, let's carry on. Question for the flat earther: what is the mole of Ci plus
Cl plus.
or
probably.
C1 plus? Sorry, or Cl plus. Sorry.
Cl plus, chlorine, right?
What is the mole of chlorine? What is it, like 19 grams or something of chlorine? 6.022 times 10 to the 23rd atoms of chlorine. Is that what you're talking about? An MOL, a mole of an element? I think if the atomic weight of chlorine is 19 point something degrees, I don't have a periodic table with me, but then the mole would be that many grams of that material.
All right. Kango 44. Let's see. Oh, hold on. Let me just scroll down here. Witsit gets it. Coming in again. Glober, do you actually not understand that if the sun is moving around the center of a vortex, the radius of orbit will increase towards the outside?
That's an interesting hypothesis with exactly zero empirical evidence. Hitchens' razor.
Right. Any other thoughts? Or yeah, let's go on. Can you Steelman sunsets on the flat Earth?
You already
Yes,
asked
it
that.
gets it. Yeah, let's carry on. Sometimes there's a little bit of issue here when I'm trying to scroll up here and check on the live chat to make sure you guys are behaving yourselves. All right, so Witsit gets it once again. He's got all kinds of questions. Another chat. Let's go up here, actually. Let's ask another question from another person. Zinaj says, has Pitch watched the most recent Artemis 1 video?
No, I have not. Is it good?
You should watch them, yeah.
Artemis 1?
Yeah, it's where they went and orbited the moon with a rocket.
That was recently.
Yeah, it was in 2022.
Did they strap a camera onto the rocket, a live camera, be able to show that it's live real time, and then fly it all the way to the moon?
There were a bunch of
way?
cameras on it, but they didn't live stream the entire thing. No.
So they switched, had cuts,
cares.
edits.
Nobody
different
gives
cameras.
a damn about that. NASA's not trying to prove anything to flat earthers. The people that they report to are not flat earthers and are not standing there. Well, you need to prove to me that. No. They just say, look, you go to the moon, you do this. And why is your budget so much over the top? You know,
They got to
tighten up your
most of the
budget, Artemis.
Yeah, except for don't worry about making it rain over the dry crops or over fires, because they can't make it rain. Look up H2O factory on YouTube. NASA makes it rain. They can make it rain on our public tax dollar, and they do not.
Off topic. Come on.
Consider the organization, the ethics and morals. I'd help the people if I could make it rain. Dubai does
Let's
it.
carry on. Taking Back Eden says, GD, do you reject ancient Hebrew cosmology? Why?
Because it doesn't match reality.
Okay. Taking Back Eden follows up. Christian, would Satan use the shape to lie to people?
Yeah, he does it with flat earthers all the time. You go on Facebook and you watch flat earthers lie over and over and over. I have a folder of lies flirfs tell. It's got hundreds of memes in it.
Question was for the Christian. So sorry, Mike. Go
Yeah,
ahead.
and if I could just add to that, with I do believe Satan is the father of lies. He can deceive people. The Bible says that even the elect could be deceived. And if you do want to talk about fraudulence, you have someone like Stephen Hawking with his Genius program, where you can see the horizon behind the board that they're saying is hidden by curvature. You can see the helicopter flipping, having doors, not having doors, the same birds flying over as the helicopter goes down, goes up. So there are, it can go, we shouldn't be, if we're trying to discover truth and be scientific here, we shouldn't be lying. No bone wars or lies about Neanderthal man or anything. Let's just be honest with the data and really try to assess together, work together, and who doesn't want to know the truth?
That's time.
So,
all right. What's it gets it coming in? Hey, heliocentrist. Can you attribute physical properties to conceptual abstractions such as privitation? Space cannot be endowed with physicality. 25 seconds.
That's Witzit's word salad misunderstanding of relativity. It's not a privation. He just says it is.
All right, let's carry on. What's it gets it comes in again? Glober. How can there be no distinction between Newton and Einstein when they're patently opposite claims? Do you know the three principles of logic? 25 seconds.
Einstein said, "No one must think that Newton's great creation can be overthrown in any real sense by this or any other theory. His clear and wide ideas will forever retain their significance as the foundation on which our modern conceptions of physics have been built." Einstein said that they do not conflict with each other. In fact, they completely agree with each other. Here's 4 citations showing that relativity solves for Newtonian gravity in our reference frame here. So there you go. mc2.net/Einstein if you want to have them all there. I even have links to the PDF, so you don't even have to Google them.
Excellent. I was just responding to some of the people in the live chat. So thank you so much for all of your questions there. And waffle before I get called out again here and get myself in trouble. All right, Max Courtney says, question for the flat earther. Actually, that one's come and gone. Witsit. See, this is what I get for skipping Witsit's questions, because he's got a whole pile of them. Sorry, MC Toon, you're gonna be busy for a second. Witsit gets it. Can gravity be a force and not a force at the same time? Can space be absolute and fixed and not absolute and fixed at the same time?
You didn't word that question right. I showed you reference there in the previous one to the agreement between Einstein and Newton. So there's I don't know why you'd think that space is fixed or whatever you're talking about there. Space is not. There's no absolute position in space.
Didn't Newton use like the universe as a background medium, so that it, like Einstein has C as a constant, whereas Newton had C plus V or C minus V, depending on the.
I don't think
frame.
Newton referenced the speed of light.
Okay.
All right. Arnold comes in and says Paul McCartney has been dead for 50 years.
What?
Yeah, haven't you heard?
Oh,
Get
yeah.
back.
Jeez, I heard a Christmas
Get
There's a
back.
song by him.
Sasquatch in the woods too.
All right.
Get back to where you once belong. All right, let's carry on.
I know.
Everybody.
I don't want to believe people would harm one another either for their own gain. I love your optimism, and I want to be there. Please, I'll go there. I'll go there. I could easily go there because I would. Who would want to hurt someone? I'm with you. All conspiracies were wrong. There's none. No one would lie, hurt, deceive. I want to be there. I love your optimism. Love it.
Oh yeah, all these years I've been wandering around, wondering how come nobody told me. Why I ain't met nobody that looked like you. All right, Wade Emberley says, why doesn't apparent size of sun change through the day?
Elevation, magnification, few factors, but elevation really does play a large role in preserving angular size and shape as an object moves. The lower down to the ground you go, the smaller distances that you cover closer to you, it will distort more. That's why we can see things along the ground appear to shrink. But if you're in the sky, there's a lot more information, a lot more span is being covered in the same unit that would be applied to the ground. The same 5 degrees, 10 degrees of ground cover. You're covering a lot more sky with 10 degrees, a lot more distance that preserves the integrity of the shape and size.
All right, let's carry on. I knew I was wrong. It was all I've been looking for was somebody that looked like you. I messed it up. I hate that. EM for $4.99 says NASA gets all eclipse or exclipse. That's what they put. NASA gets all eclipse info from Fred Espenak and his work through Sorrow's cycle. Nothing has changed.
Actually, that is wholly incorrect. You can go right to NASA's website and read about it. It costs you exactly nothing to go to their website, where they give details about how Fred Espenak specifically does these predictions here. He uses the VSOP 87 ephemeris and the ELP 2000 ephemeris to do this. These are an ephemeris is it shows where the celestial objects are within the solar system at different points in time. So that's how it's done. It doesn't use the Sorrow cycles for anything other than just naming conventions.
All right. Jam says, hold on. The one before that, let's see. Wade Emberley, why doesn't apparent sun size change through the day?
I think we got that one.
Yeah. Hold on a second here. My mouse is being a pain in the butt. It's because I got the extra one next to it for when I'm doing all my MasterCard nonsense. Marcus Ween, $10. Question for Pitch Lumen. What is the circumference and the radius of the flat Earth?
The radius and the circumference, like around the edge, is probably, I don't know, so like the coastline of Antarctica, 60,000 kilometers, maybe. The radius would be what, 90 degrees, 180 times 60, so like 6, 4, 10, 1080 or something. I don't have the measurements off the top of my head. I'm just I'm not. Let me get a tape measure and I'll
It would have to be
lay it out.
40,000 kilometers times pi.
So 120,
good.
120 kilometers, 125, 127, 130 kilometers, somewhere in that. Yeah. Okay.
All right. I'm just going to, as I extra tuck my work unit away so I don't accidentally touch my stuff that I have to do for my work job during the day. Witsit Gets It asks, YT wouldn't let me type his name actually.
Yeah, and other people typed my name.
I don't know what that's all about. Well, I got you figured out. You're back in the live chat. Kick butt. Have fun. play with some of the people in the live chat. You know, you're hanging out in the live chat. You can tag Mattoon live. He's hanging out there. So Witsit Gets It says the Elias effect was actually observed and confirmed 17 years straight in Harvard. It directly correlated to periodically the sun, moon, and solar motion. 25 seconds.
I read the experiments that NASA published in was it 99, somewhere around 2000 plus or minus a couple years. They did not confirm it. So one guy's experiment is once, and then you need external independent confirmation. There was none.
All right. Leo Crow coming in. Tune, why do you defend the globe when so many fake images of the Earth? Also, you have dedicated so much of your life to defend the globe model. If the flat Earth is so stupid, why do you do it?
I don't
Just a
like
little bit.
misinformation. Like the misinformation about all of the claims that you just made about pictures. Every time that I see a picture that is said to be faked, you look at it, and sometimes NASA does produce artistic renditions and they label them, or there are fakes generated by flat earthers. Who's lying about space? Flat earthers are lying about space. I got
Don't
a
do that,
folder.
flat earthers.
I got a folder.
Don't do that. What do you think about like the cloud duplication? How we can get
When they label it as an artist rendition, then it's an artist rendition. So what? The actual photographs that you can get on photographic film from the Apollo missions, you can go into the museum and look at. Those are not labeled as artist renditions. They don't have photograph or cloud reproductions and copy pasting.
Could you discern that from a picture taken of a model?
You would need to have an awful lot of models, and so then I would just simply ask, who are the names of the people that made the models? How many models did they make? Where did they house them? Where's the evidence for that? Claims without evidence are dismissed without evidence.
Maybe if people thought it was to help with the Cold War, just in case we couldn't go to the moon, we could potentially fake it really well so that Russia would buy it.
Hitchens razor.
Let's carry on there, everybody. If you see me laughing, it's not because I'm responding to either one of what our live chats are saying. My daughter is right behind me on the couch, snoring very loudly, and I'm very concerned that you're going to hear her. So if you hear any,
You're good. It's not coming through. You're good.
that's just in my 9-year-old. All right, so Chink Avenger says to Nathan, does light bend towards or away from the denser medium? Why does light have to bend to cause an object to appear lower?
Light bends down in a denser medium. And what was the second part of the question?
Second part, which way does light have to bend to cause an object to appear lower?
Up.
No thoughts?
Because it's inverse, right? If it bends down, it appears higher. If it bends up, it appears lower.
Okay. Any thoughts there, Mike, or do you want to carry on?
No.
All right, let's carry on. Let's see. Question for Pitchulum. What is the circumference and the radius of the flat Earth?
With that one.
Oh, we already got through that one. Oh my goodness. Yeah, we are getting close to the end. My goodness. I pop into the live chat every once in a while just to make sure everybody's behaving themselves. But it seems like my little scroller is getting smaller and smaller. So that's good. You guys will be out of here in better time than I thought. And if I get a little screwed up, it's because, yeah, as you can tell, I'm a daily driver for these kids over here. So yeah, my head.
It's late for you too.
It's just swirling all the time. Witsit Gets It. To clarify, did Toon actually just say that anisotropic, sorry, a preferred direction propagation of GPS signals would not refute reality? You sure?
No, I just said probably not to his claim. The thing is that the medium through which it's going, air and other particles, is also anisotropic, so it matches reality and predictions. Yeah. So his claim, see, his claim rests on the absolute necessity that he's leaving out is that the medium between the sender and the receiver is isotropic, but it's anisotropic, just like the timing is.
Nathan, you're kind of nodding along. Yeah, you're good to go.
I don't know
All
if
right.
Nathan got that topic.
No,
Yes.
I think there is something to the way light travels. And yeah, anyway, no, go ahead.
Aaron Reese coming in. Nathan, if objects disappear bottom up, then why don't camera lenses have a greater zoom factor at the bottom of the lens? How do you turn the camera sideways without side distortion?
The lens is taking in the light that it can based on where it's positioned, what its f-stop is, and how wide the aperture is. And then it takes in that light, and the lens is one piece. I'm sure if you added a second lens only to the bottom portion, it would distort what the bottom of the camera is taking in because it's going through another lens. And then turning it sideways, side distortion. I mean, lenses do distort. You have to put like a correction into them to try to straighten them out a little bit. And I think certain lenses distort more than others, and so would require more or less correction. So,
All right. Let's carry on, everybody. Let's move on to our last Wits It Gets It question. Are you scared to come to the after show? Says Wits It Gets It.
Not at all. You know, wouldn't it be nice if Witsit came on here and debated measurements of flatness with me? Do you think he'd do that? Measurements of flatness? Probably not.
I would contest those four lights
Probably
observation as an observation of
That's not a
flatness.
measurement.
Well,
Measurements have numbers.
C. Davis is coming in, guys, as asking, McToon, how far away is the sun from an ocean side observer as it appears below the physical horizon?
How far away is it? It's about 150 million kilometers.
I should celebrate your third super chat on our stream there because I see that tagged in our stream there, and I should remember those. I just I suck. That's the real truth of it, everybody.
No, you don't.
I'm the worst. All right, so Wits It Gets It coming in again. The Newtonian space is absolute and fixed. Keep ducking the question though. Can space be absolute and fixed and not absolute and fixed at the same time?
Nice bait and switch there. So Newtonian gravity is not Newtonian space, right? The Newtonian gravity, what people call Newtonian gravity, is the law of gravitational attraction. So the law of gravitational attraction is empirically confirmed, never been falsified. The Newtonian space stuff was his interpretation of space, a separate topic. So it's a bait and switch there that he's doing because they both have Newtonian in the name there. He's trying to equate them. So it's a false equivalency, is really what it is.
Wouldn't if Newtonian ideals were the main stake of our understanding of cosmology, then you would get rid of 4D space-time fabric and you would go back to 3D orbital motion, which
but they're
would then
not.
be measurable.
They're not. You'd go to Kepler for that.
Let's carry on. That's been my tag of the evening. Let's carry on. Chronic Avenger says for our last super chat. Actually, we got a couple other ones here. So let's second last. Chronic Avenger. How is light bent up if denser medium is down? Any thoughts on the panel there? No.
Light is bent down when the denser medium is down, causing things to appear higher.
All right, for MC Toon, if your goal was to hide the true shape of the Earth to the majority of people and you have unlimited budget, how would you do it?
How would I do it? I don't know. The flat earthers are doing their best. They don't have much budget, so they do a good job hiding the shape of the Earth for a small number of people, and it's fun. It's fun to poke at them a little bit, but nobody takes them seriously.
small number of people. I think in like 2019, flat Earth was like one of the most searched terms, and like it got even over like former president and everything. I think it got pretty popular. It actually required the censorship boxes, the free speech stifling, censorship,
Yeah, but
wiki
still
boxes
a
under
small
videos
number,
and everything.
Nathan. Still a small number.
It's growing more and more. One nice thing about multiple person debates is it shows there's many, multiple people who have this kind of hold a view like this. And I think it is kind of odd too that someone who is like a PhD can say, who works with geology can say it actually rather difficult to try to determine if it's a sphere or flat, at least at the distances that humans perceive and operate at and measure at. I think that's striking.
All right. Let's see. We got one last question, and then we'll go to our closing statements, everybody. And then we'll move on to all of our after shows and all the fun things that we're going to do after we have the real juice here at Modern Day Debate. Social IQ says, for MC Tune, if your goal was to hide the true shape of the Earth, the
Yeah, I already read
majority
it.
of people, yeah, sorry, that is okay. You know what? Yeah, you're right. That was supposed to be the last one, and I literally I copied and pasted that as an extra. So you know what? I've
You got
messed
it?
this all up. Yeah, this is great. Yep, everything's been read through. I don't need to and hum my way through it anymore. So, how much do you guys want for closing? 1 or 2 minutes?
Just a minute's fine with me.
1 minute. All right, on the floor for you. Over to you, pitch.
So I thank you, MDD, Mike as well, Mike and MDD, for being here, for the time, for the cordial conversation, the back and forth. And I did learn some stuff and have some things to look into. I just wanted to say that I think there's a lot to consider here. There's a lot of things at play, a lot of things that need to be demonstrated and can be demonstrated. I would hope people would think that would see that the flat Earth can explain things, can demo things, and is at least able to apply concepts or show concepts, demonstration of concepts. And so I want to thank everybody. I really do think that this has some spiritual implications either way, especially leading towards peace, religious wars or regular wars, liars, deceivers. And I just wanted to actually throw this out here. Just decide anyone who wants to, as far as like spiritual stuff or biblical, the YouTube channel, The Truth is Stranger Than Fiction, is a fantastic channel. He does amazing work. The Truth is Stranger Than Fiction. And he doesn't know I'm saying anything, but I just want to shout him out because he puts a lot of work out there that covers a lot of concepts. And I just wanted to throw that out. But really, thank you. Thank you both for allowing this. And I had a blast. So
No problem at all. Thanks for being here. And if anything I've learned is to, just keep everything in the fan funding and don't copy any of these super chats into notes. Just keep it all on the YouTube because that just confused the heck out of me. Mike, you got a minute on the floor. Closing thoughts.
Yep. All right. I'll wrap up one thing because Witsit was crying about my my steel man of the flat Earth sunset. Let me remind everybody that
He's going to be coming for you. I'm
Witsit
sorry,
said,
Mike. He's going to come for you now. Go for it.
You done?
Yeah, go for it. I was
Let
just
me
saying,
remind
you called him out, so.
You weren't done. Let me remind everybody, Witsit said this.
We don't have a model.
So I can't straw man your model because it does not exist. What I did, Witsit, is I computed the consequences of your claims, and the sun could never set over flat Earth. If you can compute the consequences differently, let me know. Anyway, thank you to Ryan and to Nathan for this. It was a great conversation, much better than the one that started last week. So thank you for that.
Did it start?
Well, not really. So specifically, Witsit, measurements of flatness, and measurements have numbers, units, and best if they have a margin of error analysis. Bring it up. Do you got the stones? Also, I'd like to say that Nathan Thompson had a chance to debate me, but he decided to show that he knows that I would beat him and duck out. Same thing for Flat Earth Dave and Eric Dubay and these other guys. When they refuse to debate me, it's them acknowledging that they don't have anything. So That's what I got.
I'll shoot
Thanks,
debate, Mike.
everybody.
Nice guy.
All right. Well, let's close it out there, everybody. So if you haven't had a chance to already hit the like button, do so. I'm sorry if I had interrupted you there, Mike, during your closing. I was just having some fun with your implications
Giving you
to
crap.
Witsit there. No, it's fine. You know, I take it with super, super stride. Don't worry about that at all. Look forward to hosting you again, and as you as well, Nathan. We'll have all kinds of lots of discussions here on Modern Day Debate. Once again, share this out in those contentious spaces you like having these discussions. We're gonna close it out. Cheers, everybody. Have a
Peace
good
be
night.
with you.
Thank you. All right, I'm sticking around here, guys, on this channel, so don't
we
don't
go.
go away.
All right, that is
Well-
closed.
All right, thank you, Nathan and Ryan. I'm gonna go back to my channel. I got a bunch of stuff over there coming up, so
A1. Well, I
Mike,
was gonna
take
say
care.
I
Let's
was
let's
not
keep in
lying.
contact. We're trying to set some experiments up.
I was
Did
not
you
lying.
wait? What
I had
did you
about-
like that Thai restaurant? It's so hot, dude. The food there is so hot.
Oh,
yeah, I like it. I like spicy.
why is it that
That's by
all
my
these
house,
white
actually. It's
people
by my-
why did all the white people conquer all this stuff and go after the spices as we did, and to not spice our food? We may as well.
They're
you know,
so
like,
good. It's
what
not
was
like a
the whole
Norwegian-
reason
Norwegian
of that
Christmas. Everything's
original-
white except for salt and pepper, well, except for the pepper. But they use just a
let's
little.
go to India to get
All
the
right.
spices. That was
Oh,
the thing.
All
All
right,
right,
guys,
so
I'm
all
gonna
right.
go. Thank you.
Cheers,
Mike,
buddy.
take care. Thank you so much, Mike. It was great. You're really great. You're a great guy, Mike.
All right.
So thank you for this.
Thanks, Nathan. You're too kind. It was a
Cheers,
good
buddy.
it was a good talk. All right. See ya.
All right.
All right. It did not go too long, about half an hour longer. I had to moderate the moderator a little bit. He kept getting off topic. Yes, Nathan Thompson did duck out. I asked James if Nathan could come on, and Nathan's like, I need 200 bucks. So somebody posted a $400 GoFundMe to give to the Humane Society. So let me see if I can find who was that. I forget who did that. Anyway, so I'll post it on Facebook. Be looking on Facebook for that, and maybe he can be swayed to step up, to search deep in his courage to face me. If people will give $200 or $400 to his the Humane Society in his name. So, but Facty says, wow, all Nathans the same? No. Flat Earth Nathans are all liars. Well, yeah, I mean, lying goes hand in hand with Flat Earth. So, so there's that. And so when they're asking about the spiritual stuff, I'm like, why Flat Earthers can't stop lying. That's all they do all day long. You go on Facebook, you just look at the memes they post over and over and over and over and over. Yeah, somebody sent me this. Will Duffy sent me this. I'm going to read this. Witsit just sent a super chat asking you to Steelman sunsets on a flat Earth. Tell him you can't, because in their model the sun disappears from view because it's farther away. But the problem with that idea is flat Earthers show things like the Canigou Mountain being seen in front of the setting sun, and the sun is huge at the horizon, which contradicts the idea that the sun disappears because it's so far away. Things get smaller when they're farther away, not big like the Canigou Mountain silhouette. Exactly. Thank you, Will Duffy. If you don't remember, Will Duffy debated Witsit and got Witsit quivering, shaking in his boots. It was really a good debate. So, all right, let me read a couple super chats here. Mr. QTube, first name Fa, says, holy word salad Batman. Yeah, so he's good at saying a whole bunch of hypotheses with no empirical backing. He gets that from other flat earthers. They all just kind of exchange ideas amongst themselves. So when they're like in the flat earth model, you don't know. A model includes, confirmation. Like you didn't get there yet, actually. Yeah. You need to provide, reasons for things happening. Why does the sun move in and out? You don't have a reason for that. That would be necessary for a model. A Cole of Varial has a $2 Canadian super chat. This says, sorry, I can't give more. Thanks. Enjoyed listening. Well, thank you very much, Cole. And he just did that. Right there. You don't need to give anything. Seriously. If it's tight, you don't need to feel like you do. Cole and I we talk a little bit on Discord. I owe him a response on something. So I'll get it. I'll get to you. Lord Illuminous Pooh says cargo goes by ship. Shipment goes by truck. You park on a driveway and drive on a parkway. A woman wears a pair of panties, but only one bra. ? English, no word good. Yeah, a pair of underwear. Lord Illuminous Pooh says, if there's a dome, where's Voyager? Yeah, I mean, that's the thing that is just an absolute given. It's just the base case for Flat Earth is everybody that I don't like is lying. That's what they have to say, right? All of these, every rocket ever has to be a lie. Or they come up with some contrived explanation for it. I don't know. Bob says MC2 and this is a test. So Witsit said he couldn't put my name in, and so he had to call me the heliocentrist or to the glober. He could have written Toon, even if he could not write MC Toon because for some reason he couldn't write that. He could have said Toon or Mike Toon or MC or McFlatty's ugly identical cousin. But he didn't do any of those. He couldn't bring himself to type the name. I get it. It's okay, Witsit. It's okay. Lord Illuminous Pooh says the dome must reach the ground. Go find and test it. Think about this. That the dome that they hypothesize has to be incredibly strong because it has to be 40,000 kilometers wide. And it's holding up what? It's holding up the waters above, right? So the mass is enormous. And then it comes down and it sits down around here somehow. And so all of this mass is pressing down on it, yet it rotates constantly. What kind of bearings does it have that it can rotate like that? Renee Enemy says, Witsit is lurking. I'm starting to think he might have a man crush on you. All right. Let's see. We got Mr. Lonely says, Dear Flurf, you'll save yourself a headache if you just admit you don't know. Then listen to the explanation given instead of could be, maybe. Could be, maybe is not an answer. If you don't know, just say you don't know. Don't throw out a could be. It's useless. And Mr. E-Man gifted 10 memberships. Thank you for that, Mr. E-Man. Be sure to thank him if you are the recipient. That was a while ago, so maybe you already have. Stringer News 1 says, touch firmament and take pics or you have nothing. Yeah, well, let's give a little bit of fairness. They say it's on the other side of the Antarctic ice wall or whatever. Well, just go, pack it up, put in the do the fundraising, put in the requisition, plan your trip, get all of the materials you need, the equipment you need to do it, and whatever flat earth cartographers that you're gonna. I couldn't keep a straight face, flat earth cartographer. Oh, John Blue says, haven't you heard? It's all ball bearings these days. I love Fletch. Great movie. Can I borrow your towel? I just hit a water buffalo with my car. Was that it? That's it. That's all I had. Adam Lapine says, missed the start. Gonna have to go back and watch later. Long time watcher, not active in chat much. Defo Flat as Flatzoid for top left. Absolutely. 2D ResQ Explain Stuff says Flurfs do math in base 0. think that was when I was bringing up the base 35 spelling of all these flat earthers that has 666 in them, which proves just as much as finding a 666 in the globe. Nothing. 2D Res Q explains stuff again, says Flurfs. Never use one word when 40 will do. All right. Alyssum says, sadly, he demonstrates that all Flurfs are stupid. He's all right. He's on the smarter end there. But yeah, he did some of the dumb. He did repeat some of the dumb stuff. You know, like the moon rock from the Netherlands. Like, you could just Google it, just look it up, how it happened. It's a way better explanation than the lame ones that the flat earthers put together. It makes sense when you look at it, because and then of course you would need to have evidence that the astronauts gave out moon rocks. They never did. So if they did give out moon rocks and there was documentation of them giving them to the Netherlands, then this showed up, you'd have a little more. So Gibberish says, how much politeness forgives a lie? No, you're right. Being polite does not forgive a lie. And I'll get to your question, Brenda. So it'll take a little longer, I think, and maybe PhD Tony can explain it. He has more background in that particular than I do, but it's a quick one, I think, really. I just said it's going to be long, then it says it's going to be quick. We'll see how long it takes. 2D Res Q explains stuff says globe Earth does not falsify the Bible. Yeah. So everybody has their own personal interpretation of whatever holy scriptures you want to reference. So if there is really no disagreement about what something says, well, then maybe you can say something. But if a bunch of people disagree on what something means because they all have a whole bunch of different interpretations of it, then you certainly can't declare that yours is the one and true interpretation, that everybody else's is wrong. That's a lot of narcissism there. Since there's a lot of disagreement, in what the Bible says about the shape of the earth, is that supposed to be God revealing some hidden truth? But the problem is, since the earth is a globe, if the Bible says that, then the Bible is wrong. So flat earthers that say that they are Bible believers are intentionally trying to defeat the reliability of the Bible. It's a weird thing for them to do. Wade Eberly says, why doesn't apparent size of sun change through the day? And he gave a lot of waffle. But none of it did he. It did not include a computation of the consequences. I tried to drill that in from the beginning, but never does. But you can't get it from a flat earther because none of them have ever done it. No flat earthers have ever computed the consequences of flat Earth. They just have some vague ideas, and that's it. That's all they need. They're easily swayed by no evidence. That's the third law of Flurf. Count Discalcula says, Nathan, 2 observers facing north, one London, UK, the other Sydney, Australia, at 7:10 UTC plus 0. What is the observed sun position for flat Earth and globe? Well, that would, for a globe, we can answer that. And NOAA, NOAA, Sol Calc has the answer there, and a spreadsheet with all the math in it. So you can confirm the computation of the consequences. That is actually happening. And C, does the globe geometry work? We work today. And then what is the observed sun position for flat Earth? Well, you'd have to take this. You'd have to determine where the sun was, the subsolar point at that moment on the Earth, because that exists and it's well known. and then you just draw a straight line, and it won't work. It never works. It's like a clock, right? A stopped clock is correct twice a day. Well, the angle to the sun is correct in a couple spots, but on either side of those spots, then they diverge in opposite directions. So I did it, and it doesn't match observations. I have done the angle to the sun, not just the elevation of the sun, the angle to the sun for flat Earth, and you can count on it not working, right? For Canigou, I did a bunch of stuff on Canigou. I haven't used this yet, but the sunset for Canigou, the angle to the sun at the moment of sunset, when you're looking at Mount Canigou with the sun behind it, does not match the angle that flat Earth demands. And they'll say, well, you're strawmanning. Okay, give me the right way. They don't have the right way. Witsit whines that I didn't steel man. How can you steel man when
we don't have a model?
You don't have a model. I can't steel man your not model. I'm the one that had to develop the model for you, and it didn't work. You think I did it wrong? Do it right. You can't do it right? Then I'll take mine, and you can't complain about it. I love just cornering them on that. If you can't compute the consequences for flat Earth, you lost. You can't even do it. You didn't show up. We are not able to have a debate if you can't begin to do something for flat Earth. What would happen on flat Earth? What is the necessary observation for flat Earth? You don't know. You can't even give me a prediction. I could do it. Globers do it all the time for you. And you reject it when we do it without replacing it. You lose. You always lose. 2D Rescue Explains Stuff says, I cannot begin to express how relieved I am to compute the consequences of his disproving the sun running via nuclear fusion. Hydrogen bombs don't work. We're all saved. I don't know what word salad he had. Of course, in that was a super chat from a flatty there that expected, this isn't the topic of this debate, but okay. What is the specific, empirical tests of the things that are happening, the fusion that are happening within the sun? They exist. I don't have them handy, but they do exist, and you could look them up, Flatty. Now, the problem, of course, for flat Earth is, how does it work for flat Earth? It's hypocrisy. If you are expecting me to come up with the answer to it, it exists. If you really want it, you want me to do that research on your behalf? I can. You're too lazy to do it. I get it. Or it's confusing for you. Definitely. But you don't have an explanation for flat Earth. What is the source of heat and light for the sun for flat Earth? Nothing. You have nothing. Just again, it's a constant lose train for flat Earth. All right. We get to Brenda says, could explain the question about GPS and anisotropy. Okay. So that was that from Toby, I think, or Witsit. So there's some GPS time measurements where they're finding that the time that it takes for a signal to get from a GPS satellite orbiting the globe to the receiver on the ground, it's the first law of Flurf. They're trying to disprove special relativity by using satellites orbiting the globe. Think about that. And then on the other side of their disproof of special relativity, they say, therefore Earth flat, because they think that disproving relativity automatically makes that assumption, which it doesn't. There are many people that disagree with relativity and say this is how it works using the globe. So it's a complete non sequitur, but whatever. So the timing is inconsistent between them because the air between the air and the atmosphere and the ionosphere between the satellite and the observer is also anisotropic. And the refraction happens because light goes slower in different mediums. So when it goes through different mediums, light goes slower, right? So because the medium between the satellite and the receiver is inconsistent, it's not perfectly identical, and our resolution of the measurement devices is fine-tuned enough to be able to identify these slight variations. That's why it's anisotropic. And I did say it wrong. I'm gonna blame Ryan for him reading it wrong. I should have caught it and said it correctly. Anyway, so I don't want to push it off on him. So, Nerd Alert says Whitsitt is complaining that YouTube has demonetized his channel and wants to sue them for $100 million in damages for violating his First Amendment rights. This is not a joke. And you see this a lot of the time with dumb people. They think that somebody else's platform is automatically their platform. And if that other company, not government, that other company chooses not to allow them to use their platform, that then they think somehow their First Amendment right was violated. That's not the First Amendment. The First Amendment says that Congress can't make laws restricting your freedom of speech. It doesn't say that everybody must allow everybody else to use their platform to say whatever they want, which is what Whitsitt thinks. So YouTube is a private company, or publicly traded, but it's an independent company. It's not the government. They get to choose what people say on their platform. Just like within my own channel, and just like within Whitsitt's own channel, we each get a little bit of YouTube, and YouTube grants us the privilege of choosing what speech we allow on our little slice of their larger platform. So Whitsitt, if you're going to whine about that, then anybody that has ever blocked somebody in YouTube should also get to sue the channel that blocked them. So Whitsitt, if your block list is non-empty, then every one of those should be able to sue you for $100 million by the same token. Be sure to send them your lawsuit details. CV McCullers says, Doctor, you know it. I don't know it. I don't know what you're talking about. And Gibberish 001 says, can you talk about the vanishing point not being a real point in the distance and how perspective does not move the relative position of objects? Yeah, so flat earthers, yeah, a great softball question. Thank you for that. So flat earthers talk about vanishing point. Vanishing point is a term in art. In art, the vanishing point is where everything tends to converge. But of course, you can have multiple vanishing points if there's straight lines in different directions from a position. And so they're like, oh, it's a vanishing line. Well, in reality, the reason why things vanish is because they're too small. Not because they're partially obstructed by something. So the sun is partially obstructed by the horizon, right? This is, let me get it so I can see, right? Here's the horizon, right? Well, it's I want to see the flat earth there. It's a curve like that, right? And here's the sun. It's a Space Force logo patch. Here's the sun. It goes and it gets blocked, partially blocked by the horizon. They're like, you can zoom it in. The sun has never been zoomed in. If you could zoom it in, you could zoom it in after it sets. Never been done. So how's that happen on flat earth? It doesn't, but perfectly predicted on the globe. So again, you compute the consequences. On the globe, it should be obstructed. On flat earth, you can't compute it. You just have a bunch of vague ideas. Andrea Huddle says he kept mentioning the sun increasing in size due to refraction, etc., at the horizon, but doesn't apply that to boats or anything else on the horizon. Shouldn't everything be bigger than? Yes. So he's actually parroting Rob Skiba. So Rob Skiba, who is an actor, not a scientist, not anybody that had a clue about anything in this field, claimed with zero evidence that water droplets in the air will cause things to appear larger. Let's think about that for a second. All around you, there's 360 degrees, right? And all around you is this water that apparently is everywhere, even in the desert, because in the desert, the sun sets too and doesn't change in angular size. How's that happen? No idea. Anyway, 360 degrees all the way around you. If it makes things bigger, then everything has to get bigger simultaneously. But then where do they go horizontally? They can't get bigger horizontally. There's nowhere for them to go. If something's here and something's here all the way around you, then this one gets bigger. These have to get crowded out. They can't get crowded out. That doesn't work, right? You don't see that. So that's not what happens. When people talk about atmospheric lensing, it's a horizontal lens, not a circular lens, horizontal. And you can see the effects of it because just like the horizontal, there isn't room for it. You can't just have everything get bigger. Where would it go? Well, when you do horizontal compression, there's no room. So what happens? Horizontal magnification. You have these things and you're going to have another one in here and another one in here, another one. Well, these things have to get compressed. That's what happens, right? So it's not compressed and you add these things in, they get compressed. You can see that if you look at like buildings that have windows on them where they're all the same size, when they're lower to the ground, they're squished. So it's getting the same amount of stuff there, or a larger amount of stuff in that area in the same amount of space. It has to compress it for that to happen. Empirically confirmed, that's what happens on the globe. It would happen if the Earth were flat too. But it wouldn't cause things to be missing. It would cause things to be raised up, but also squished together. Marcus Wynn says, my favorite thing is to ask flat earthers about circumference and radius. Yeah, that's a great question. Even this map here it's not a scale, right? This ruler looking thing here, you couldn't cut that out and put it on here and tell you how far distances are. It doesn't work. It's not a scale, but it does say that this top one is a nautical mile to imperial mile converter. It's basically a slide rule, a one function slide rule. And the bottom one is I forgot what that one is. It's not distances on here, but it does say 60 nautical miles per degree. And that's true. That's what happens on lines of latitude. Well, 60 nautical miles, 111 kilometers. So the diameter of flat Earth is 40,000 kilometers. Has to be. This map says so. We can measure it in reality. So that tells us the radius there, right? 40,000 times pi. 120,000 more than that, but right. And so then by the same token, the radius of the equator, the circumference of the equator is 20,000 times pi. But in reality, we don't observe that. You can go measure the equator. It doesn't match that. So, yeah. One thing, some people have said you can't do it, but I disagree. You can take latitude, longitude, and shoehorn them into polar coordinates by making latitude be a measure of distance instead of degrees. Just convert 1 degree to 60 nautical miles. But it doesn't matter because as soon as you start doing what it implies, it doesn't work. So 40,000 times pi, that's one heck of a Thanksgiving dinner. Okay, somebody asked, Gigi asked, I don't know, up here, how do I rectify my religious beliefs with science? Well, science and religion don't conflict, unless some people choose to have them conflict for dumb reasons, like flat earthers do. Why? So what was I? I don't want to. It's they don't have to, and religion is non-empirical, right? It's not. It's not a science. It's not making scientific claims. If it does, then test it scientifically. If somebody does, test it scientifically. If it's wrong, it's wrong. So, and that's an important part of science. If you look at the Vienna Circle and Popper, and others at the time in the early 1900s, they were making distinctions between metaphysical and science, and what science can do is not metaphysical. So religion is outside of science. So anybody, when you start to try to bring it in, you're going to run into trouble. So like somehow try to make a claim, like they like to read the Bible, flat earthers do, and then demand that what it says there is actually speaking about reality. And when it doesn't match reality, they substitute reality and replace it with their own. Yeah. All right. Witsit is on the Matters Now after show if you want to join. Oh dear, is he? All right. The bathroom one more time. I think. Let's see. I just go over there. Right with this. Is he? I don't see it. Hold on. Home. There it is. Okay. Oh, it's full of people. I see Witsit there. All right. All right. Tell you what, I will play it. I'm gonna hit the bathroom, then I'll come back. But let me get it up here so you all can see it. There it is, and let me get it so you can hear it.
Space, and I think that is another. It's another under level that we see in these kind of conversations, and I think it kind of sort of forms where people are at in these particular conversations. So for me, I think who won, it was, I'm going to call it a tie, because I didn't really feel swayed by either. So, yeah.
Thank you very much. And my opinion is for a novice debater, like I think Nathan is, he did very well. And I do like that he is actually nice, because I am kind of like that. So I kind of relate to him in that sense. I prefer the debates when they are nice. The last debate we had about the Trinity and the Tawhid, the chat was absolutely insane, and I kind of hated every moment of that debate because the chat wouldn't stop insulting them no matter what I did. So I think there's room to have these conversations without having to attack someone. And regarding what you said before we went back into the conversations with it, I think bringing someone's family is it's a low blow and should never be done. If you want to attack the arguments and let people have their families, be happy, and mind your own business. I absolutely disagree when people bring families into this. That's a no-go for me.
100%. Can I say one thing too about word salad?
Yes.
I've found this on both sides. Like when the flat earthers say, "Oh, the globers are using word salad," or the globers are saying, "Oh, the flat earthers, they're using word salad," and they never attack the argument, or like they either don't understand what they're being told, or basically they're using a cloud of, "Oh, you're just using word salad," to admit I don't understand what you're saying, and therefore your argument is invalid. I think that needs to change too on both sides.
Yes, we can totally get behind that, but there's
don't have a
also
model.
a little bit of responsibility
I
within
need to
the debaters
do a little
themselves
bit of audio
that
here. Hold on.
your opponent might be able to keep up with what you're saying, but we always have to bear in mind that there's an audience in which there's a wide range of people, so we should try to
We don't have a model.
communicate to the biggest average of people we can find. So I think there's also a fair criticism to be made.
So I
there.
agree with, I think it was Isa that said it, that which should be hyper simplified and simplified for the audience, and I 100% agree with that. I agree that from a globe perspective, when go onto these papers, and I do want to point out that the reason why people thought the science tells you that these things are wrong, like he could bring up papers, he could do all of that. It's just, it would take way longer. It would take like half an hour. So I think just sort of saying, hey, produce a paper that conflicts with the known science is the best he could do. I think that what distinguishes word salad from actual sort of technical language,
it's
is
cutting out.
Anybody challenged in a technical field should be able. So when you go to MC Toon and say, hey, I don't understand what you're saying, or you're using word salad, explain why.
That was cutting out. Let me see if it's
a globe, an indication when someone is using word salad, when they refuse to explain it in simple terms and just want to move on.
This goes to show
usually been my experience.
You guys don't know what word salad means, man. I don't know how many times we have to define it, though. There's a different complaint that you have that people are talking.
Interrupted me.
I thought you were done, man.
Of course,
you just
right over the top of me.
All right.
Okay, please keep going.
Yeah, good job, Whitson.
Yeah.
So the problem is, so when I go into StreamYard, it cuts out for some people, and this happened last time I was on with Matters Now. So it's unbearable to be on there. It cuts out all the time. So I don't know
what the words they're using means. And occasionally we've seen things just put together. What's a good example? Like the other day when I was debating Nadir, and he sort of said scientific miracle kind of thing. Now we refer to scientific miracles as sort of a certain thing, but that's just word salad. It doesn't mean anything in a real literal sense. So he's just trying to string, and like Deepak Chopra, who strings together the quantum spiritual. Are you okay with it? Are you okay down there, mate?
No, we got to listen to you for 5 minutes at a time, I guess.
Oh, poor Witch coming
from you. I'll give you.
Wow.
I'll give you an extensive turn.
What a lovely guy!
After.
What a lovely.
Well, this guy lied about me. Then we paused it and we went through the room, and now we went back to him after he lied about me, without me getting to call out.
I'll give you a turn right after.
What did I lie about? I've been slandered now. What did I lie about?
All right.
Oh, okay. I'll go. Okay, so you pushed the lie from MC Toon. This is going to expose both you guys. This is awesome.
Can we stop talking about MC Toon while he's not
Oh man,
here?
crazy man! I thought
like just stop talking.
He can't stop talking about me.
Yeah, I don't know. It's weird.
Austin reply and
just personally attack people, sure.
Okay, so you lied about me, and it's a lie that MC. I'm trying to say it. It's a lie that MC Toon put on his channel, and it came from Bryant and MC Toon. That I tried to put off ChatGPT papers as if they were real, and got busted for doing it. Now, here's the actual truth of what happened, and think about how gross this is that you guys are still saying it. I went to ChatGPT to ask for additional papers regarding thunderstorm activity and gravimeters because I couldn't find a couple that I had read before. It gave me a list of papers and I couldn't find them. I then went to Bryant Myers and said, hey, since you used to be a professor, do you by chance have access to a database that could find these papers? I can't find them anywhere. I can't verify them. Then he sent them to MC Toon, who then lied and made a video claiming I presented them as actual, real, legitimate papers, and I just didn't know it, and I was actually just randomly pasting things from ChatGPT and claiming they were real. Imagine how gross of a lie that is, and you guys are still saying it, and I've publicly corrected it 10 times. And you guys don't know what word salad is. Word salad is something that's incoherent, meaning that the...
Yeah, a lot of his stuff is incoherent. All right. Witsit caught lying. One right here. Witsit sent an email to Brian asking him to look up some papers that Austin tracked down. But most of them are behind paywall or institutional access. So, Ola, my friend, hope you're doing well. I finally tracked down these papers about thunderstorms. He didn't say, I finally got them from ChatGPT, affecting gravimeter readings and downward acceleration rates, but most of them are behind paywall. I was wondering if you could get access, right? And then when he asked them, I asked him, what do you mean? Those links don't even match the titles. Did Gleam give you them? This is Bryant on the bottom here, right? Did Gleam give you them? Cut and paste links and compare titles. You see what I'm talking about? Yeah, I think I had them get all mixed up. It's a mess. Had them get all mixed up. You mean when you asked ChatGPT for them? Haha, no, Gleam did not give them to me. But check this paper out. Turns out I wasn't crazy at it, right? So and that particular paper is about gravitation. I think if I remember that one right, it's about the mass of water in the air changing gravitational acceleration. It doesn't help you. So I sent you those papers after getting them mixed up. But this time the bulk of the emails was diversion number 2. So let's see. What does this say? I sent you those papers after getting a lot of them mixed up on accident. Oh, and I guess someone's sending me bad links or something. Still haven't figured it out. And you immediately... Someone's sending me bad links? Someone sending me bad links is ChatGPT. Is that what that is? No, he's trying to blow off that he tried to divert away from the fact that he used ChatGPT to get them. And someone sending me some bad links. Not someone, ChatGPT. And then this is my absolute favorite here. You haven't even read the paper and you're telling me it's trash based. Anyway, get this. You see these alternating dark and light lines. This is copy pasted from ChatGPT without removing the formatting. Right? This is exactly what ChatGPT outputs. So he had asked ChatGPT to equate Coulomb's law and the law of gravitational attraction, because you can see right here Coulomb's law on the let's see if it's on the screen there. You can't quite see it. So there it is. The top line, F equals Q or K Q1 Q2 over R squared, and then 1, 2, 3, 4, 5, 6 down is the law of gravitational attraction, and it's doing these. That first section doesn't have much algebra. Then we get down here to this Fg equals Fe. What's Fe? Well, Fe isn't used before. Equals, and then the law of gravitation, Coulomb's law, sort of, right? K times Q squared. So that's if both Q's are the same charge, over 2R squared. Where'd the 2 come from? Where'd that? Don't know. Where Q is a charge of a proton, solving for G. There's no G in there. You see, Witsit didn't even catch these things. How can you solve for G when there's no G? G equals M1 over R squared equals K Q squared over 4R squared M1. Now, how did this happen? This is all just goofiness. But that's beside the point of him claiming that it was someone else. Someone else. So let's see what he has to say.
They're using word salad, and they never attack the argument, or like they either don't understand what they're being told, or basically they're using a cloud of, you're just using word salad to admit I don't understand what you're saying, and
words don't even like coherently. I can read the definition from Google. Right? The literal definition is incoherent babbling that typically is associated with schizophrenia. It isn't just, that's the actual definition of word salad. Do we need to share screen and pull it up? Because that's objectively what it is. And so it's not, you guys are talking about a different complaint, which is where people are talking overcomplicated terms to confuse the audience without any true substance or specificity in their claim. That's what you're trying to say. That isn't called word salad, right? And give you an example, and I'll stop talking. My super chat to McToon was, can you attribute physical properties to conceptual abstractions such as a privation? Space cannot be endowed with physicality. And he said, that's just typical Witsit word salad. Okay, no, if you can't comprehend that statement, that doesn't mean it's word salad. It's objectively substantive, specific, and coherent. So if you guys would just stop saying it, because I've asked every Globerther, name one thing specifically I've said that's word salad, and not one of them in 4 years have been able to name one example. Not one time, but hundreds of you guys still say it. So I think it's kind of a way to do what Rex said, which is dismiss our point because you don't understand it. That's obviously what it is. You can't actually rebut the point, so you have to find a way to dismiss it.
Oh, obviously.
Mark.
Let's
okay,
have a
so
listen.
for a start, I didn't get the list from ChatGPT from MC2.
Let's have a listen
on the moon phases real quick. I was curious, what is a full moon and what is a new moon on your model?
I think it's probably like a magnetic cycle, and just like the center of a Ferrel cell image of a magnet, it's just completely black. It's actually just pure inertia, and the center, the Ferrel cell image of a magnet. I think that's what it is. It just actually goes into its inertial state.
It goes into its inertial state. What's its inertial state? That's not a thing.
Then charges back up, and once it
then charges back up, there's charge to inertia.
Becomes like etherically displaced again. You start to
etherically displaced. That's not a thing.
See it charge up throughout a cycle, and it goes back.
Have you ever had a dream that you want him to do you so much you could do anything?
On the moon phases.
All right, Shay, could somebody post that into there so that I can listen to him word salad?
I don't really watch NC2. I don't really pay attention to him. Now, I was watching the debate where you brought it up and tried to look for the citations. When they didn't bring up anything, I was in the chat. I was there when you actually brought them up, and I could not find these citations, which led me down the road of trying to find them and them coming to nothing. And then later I found out about it. So no, I didn't get it from MC2. You are completely wrong. You're making a huge assumption. I was in the chat when it happened. So sorry, mate. That's not true. I actually never got them from his website. I wrote them down after going back in the live stream and pausing it and writing them out. So you're wrong about that. I was in the chat, as I often am, as you're very aware. Now, word salad is basically just a shortcut. Yes, it can mean that in a psychological sense. We're not using it in a psychological sense. We're using it in a colloquial sense. Now, what it refers to in a colloquial sense is argument by gibberish. It basically means that you've strung multiple words together that don't actually make a coherent, meaningful thing in reality. That you're actually, like I gave examples like Deepak Chopra with his quantum entanglement of particle structures in spirituality kind of thing. That is an actual sentence you can put together. It doesn't actually have any analog in reality at all. So when we're saying word salad, we're not calling you crazy. We're saying that the words strung together don't actually mean anything to the receiver. They don't mean anything. Now, it could be that they do actually mean something and that you can explain what they mean and sort of reference in the science where they are strung in that particular way to mean something. But unfortunately, you don't do that. So we don't know. So if you want to refute word salad, break down your terms to mean something to the other person and or refer to the technical language within a scientific field that you can say, hey, this is where they reference that sequence of language and this is actually what it means.
Yeah, which I do every single time when given the opportunity. Like I said, I could offer you 10 grand right now. You won't be able to name one single time I've used word salad. Not one single time ever. You can't do it. You make it up. You just claim you wrote down, I'll bet you on this too, that you wrote down papers I cited in a debate in the chat and that they were from ChatGPT. That's not true. The actual papers that came from ChatGPT were in an email I sent to Brian Myers about the electrical activity regarding a gravimeter. And I literally said in the email, I have no idea what these papers are. If they exist, I can't verify them. Can you help me find them? So you made that up. And again, I just gave a specific example, which was I said to MC2 two nights, can you attribute physical properties to conceptual abstractions, one of which is a privation? Then I said space cannot be endowed with physicality. I even offered a qualifier afterwards to make sure you understood exactly what the privation was I was referring to. If you don't know what privation is, that's fine. But actually, it doesn't remain word salad because you said so until the other person comes and explains it to you because you have inept vocabulary skill set. Isn't how that works. Word salad means it literally doesn't make coherent sense. When McToon said that's just typical Witsit word salad, he's wrong. We can break it down. What does conceptual mean? It's of the mind. It's an idea. It's a concept. Conceptual. What does abstract mean? The same thing. An abstraction is just an idea. So a conceptual abstraction, to make sure you get the point, we use two different words. And you attribute physical properties, those are pretty simple words, to conceptual abstractions, one of which is a privation, which means the absence of. Examples of a privation would be nothingness, zero, a shadow, absence of light. It's the absence of.
And that privation is the straw man. That's what I'm talking about. It's not the claim.
Something. It's nothing in and of itself. It's a privation. And you attribute physical properties to privations, and then the follow-up was space cannot be endowed with physicality. Now, those are very specific. Those aren't even big words. Those are really basic vocabulary words. Instead of answering the question that McToon's been ducking for 4 straight years, he had to say, oh, it's word salad.
It's not a privation. It's a straw man.
And that's your guys' tactic. And what happens is I get hundreds of emails that say, bro, one of the main things that woke me up to Flat Earth was every time you make very specific arguments, at first I think, what is this guy saying? This doesn't make sense. And I Google the vocabulary words and I'm like, wow, what he said is specifically accurate. It makes perfect sense. And every globe earther just claims it's word salad. And it made them go look into my claims and study it more. So you guys are making Flat Earthers when you do that. And I would appreciate if you guys just show a little good faith. It's been 4 years of you saying it. Either man up and say what I say is actually word salad, or stop saying it. It's a bad faith tactic to basically gaslight the other person.
Totally word salad.
All right, we're going to bring it back. Hold that thought for the discussion. That I just have 3 more prompts I worked for the debate, and we'll get the
all about what your arguments are. It's kind of like, yeah,
justifiable. They fumble the ball because I need to be able to. I would say that's one of the stronger ones that he made. Most of them was him kind of answering questions thrown at him because that's what MC Toon does. He shifts the burden the whole time. So
shift the burden.
Thank you very much, Toby.
What does Witsit say about shifting the burden? Just a second. Let me get it here.
The person making a positive claim has the burden of proof.
Yeah, if you say the earth is flat, then you have the burden of proof.
You make a positive claim of specificity, you have the burden of proof of specificity.
Yeah, you say the earth is flat, you have the burden of proof.
You do understand, again, that positive claims require the burden of proof.
Well, that's right, and then you make a whole bunch of claims with no evidence. But what's that?
What do you mean by religion?
A belief system built upon the doctrine of men void of empirical verifiable evidence.
No empirical verifiable evidence, Austin.
Yeah, I've liked Nathan's arguments about perception and long distance observations. I seem like he demonstrated that he understands optics. And honestly, once you understand optics and insane refraction indices that a globe has to invoke to explain long distance observations and optics, it's hard to go back, especially once you understand the way that perception works, that you perceive from a single point in a 3D space. So just necessarily you do not see the world in a perfect Euclidean geometry. That's why train tracks converge in the distance, and that's exactly what the sky and the ground do.
That is Euclidean.
In the distance at the horizon. So once you understand all that, once you really wrap your head around all that.
That's how stupid they are. They think that train tracks are non-Euclidean because they converge. No, that's Euclidean.
That's necessary whether or not you live on a globe. It's hard to go back, in my opinion. But he laid that out quite well, and he understood refraction, and he laid that out quite well. And I thought that was fantastic.
Thank you very much. Billy?
I thought his only argument that I can maybe get behind is about him saying that God and Satan maybe, and that's only because I believe them and they might be possible that they exist, but I don't personally.
All right. I've had trouble before. I want to go on there, but I can't hear anything. It's constantly cutting out. When I'm in StreamYard, when it's coming through YouTube, it's working. So it's something between my computer and StreamYard. And I haven't had any other troubles with bandwidth today. So anyway, Aaron Reese, I want kudos for the camera lens question. Such awkwardness. Yeah, you guys, you got him a whole bunch of times with. It's the same thing. It's the same thing as they always do. It's religion.
What do you mean by religion?
A belief system built upon the doctrine of men void of empirical verifiable evidence.
Void of empirical verifiable evidence. What's ether?
Ether is an immaterial background medium of pure potential. It cannot be quantified or measured intrinsically.
What do you mean by religion?
A belief system built upon the doctrine of men void of empirical verifiable evidence.
Ether is religion. By Witsit's own definition, ether is religion. So, yeah. That is flat earth to a T. Absolutely. And that was Nathan all night tonight. Every single time I asked him a question, he came up with a bunch of stuff, some vague claims, but none of it was empirical verifiable evidence. So I don't know why Witsit would go after that. I do. Because he thinks he has it. See, to him, empirical verifiable evidence is a misunderstanding of the globe. That's to him. So, all right. Well, I'm not gonna sit here and critique the after show for my after show. I can't really get on there because of the whatever network issue is. I don't know. I was having a work meeting the other day, and it was cutting out. I thought it was the person I was talking to was me. They're like, no, everybody says that it sounds fine. It was just me. So anyway, tomorrow I have another debate, so I'm gonna wrap it now. The other debate is with Vika Draziv. It's gonna be here and it's going to be on Jaren's channel. Who knows how crazy that'll get. He thinks that the Antikythera mechanism, which is just numbers in gear form, somehow is proof of a flatness. We'll see how that goes. So be looking for that, everybody. We'll see you next time. That was the wrong one. Hold on. I got to get that. That's the one. Okay. Here we go.
MC2, drop that beat.
All right. Let it flow. Let yourself go. So I know that is the tempo.
So, yeah, let's do this. So.
Let's do this. Yo, it's MC2, the debunking tycoon. I shatter flat earthers, make them face the moon. Your attempts are decent, but they'll swoon in the face of my logic like a deflated balloon.
Oh, MC2, the monsoon cartoons. I'm the real sage, sending flirts to their views. Your theories are like old brews, sweeping ignorance, or just spreading the views.
FDFB stands for fumbling the facts, evidently. I drop truth bombs so splendidly. You are prone to soft minds unrelenting. I bring the science while you're just venting.
MC2, the buffoon with silver spoons. I tackle pseudoscience, make them change their tune. You're the sidekick, I'm the rude. When it comes to debunking, I'm the rude.
All right, I missed one here. From Wade Eberly says, I think one reason flirts can't let go of the delusion is that they would be crushing to their egos to recognize what fools they have made of themselves. Very true. Dave Kircher says, thank Titicaca, it's Tuesday, and thanks to Super Tune for keeping us attached to the spinning globe. And Christian Hoage says, have I missed any positive dirt pizza evidence during this debate? You've not. Oh, and one more. Mr. E-Man says, I'm sorry for the lack of detail in one of my questions. Flat Earth needs to provide an explanation of the change in the length of the solar day without a corresponding change in the sidereal day. Good luck for that. All right, hold on a second. The Zoom call died. Everything died. No!